Okay, so welcome everybody. Welcome to the session again, DevOps Foundation course from DevOps University. Okay, team. So hope everybody is able to hear me. Here, this is Naresh here. So please do say yes if you're all able to hear me, so we can continue with our session. You can use your questions panel to say yes if you're all good. Yes, all of you. Anybody able to hear me? Okay. I do not see any responses, guys. I'm not sure if you're all able to hear me. Okay, great. Thank you so much. Tamim, thank you. Okay, great. Okay, so thank you so much, guys. Before we get started, there are two things. Two things I would like to let you know here. First thing is about the recordings that we are trying to record the sessions and everything. The recording sessions are uploading to your YouTube. So please do subscribe to the DevOps University channel on the YouTube. So you will get a notification as soon as we upload the video onto the YouTube. So you can watch all the recordings on the YouTube directly. So you do not need to wait for anything. That is one thing. And the second thing is that I see most of the people are joining from the web, right? Go to webinar web. If you are joining from the web, guys, you will not be able to unmute yourself, or neither we will be able to unmute you. So we request everybody to join from the GoToWebinar application. It is better you download a GoToWebinar application and then join through that. So we will be able to unmute you, or you will be able to speak to me at the end of the session if you would like to speak. So we request you to join from the GoToWebinar application rather than joining from the web. Please make sure you're doing that one so that you could able to speak to me. Otherwise, we will not be able to help you if you want to ask question. I think you just have to use the questions panel accordingly. Okay, so that's just two announcements, team, before we get started. Hope you all okay now, so we can get started. Okay, I think we need to look for some other option, Sajal. They might be able to, because we should have to check that one. Maybe we'll check that later. That's okay. Maybe you can join from the mobile also. I think mobile applications are available, I believe. Not sure, but let's check that one. Okay.
Naresh, could you please hold for a couple of minutes? I am sending invite to everyone so people can quickly register and join. It might, solve their problem. I'm just sending an email to everyone.
Okay. So guys, I hope everybody heard that voice from the Kumar. So you will be getting a link, I believe, so to register and join. That way it will be easy for you to join, I believe. Okay. Okay, so meanwhile, right, I can quickly talk about the agenda for today, guys. Today we are trying to discuss about the Git as a source code management tool. We'll just try to understand on top level team what exactly is source code management tool and how we use it, or how the developers will be using it, the basic commands that we're going to learn it. I'm going to share all the commands. In fact, a little bit more content will be shared for you accordingly, so you can go and practice later after the session by watching the video and whatever you want to do it. That is the first part of the session. We're going to work on it. And the second part, we're going to work on the Jenkins and Maven. So after the source code is ready, what exactly we do with that source code, or how do we take this source code and then deploy into various environments maybe. So these two are the topics which I'm trying to cover today. So we will try to cover as much as we can. We will be covering, again, I'm telling you, Git as a source code management tool, and then Jenkins, Maven as a build automation tools. What exactly we need it, or why exactly we need those tools. We're going to discuss about these things accordingly. Okay. Okay, so yes, Nayak, so you will be able to, I think Kumar is sending you the new link where you can register and you can do it, I believe. That will be coming to you. So hopefully you should be able to register and able to log in. So we'll take care of that one. Okay, so I think Kumar, I think we can get started, right? I believe we're losing the
I
time also.
WhatsApp to them so they can quickly join. I don't know why these people are facing the problem. Very first time we are seeing this kind of issue.
The new link does not work. Nike pinks there in the question. So the new link is not working. It seems Nike. Sorry, Kumar.
New link is you have to just click on that link and enter your detail, and you will get the email.
Yes, Sajal, we'll try to do that definitely. But right now we will continue with this. Definitely, we'll try to look into that option. Okay. I see couple of are able to join with the application. I believe is Srikala and then Samutivel. Gopal, you can just watch the yesterday video. I think it's already uploaded. You will be able to see that for sure. Yesterday, I have already demonstrated how to connect with the instances. So repeating the same thing will, we may not be able to show that again. Please watch the yesterday video at the end and you will be able to see that. I hope you got the links for the yesterday recording already. So please read that one. Okay. Right. Okay, I think people may join. I believe we should be starting, Kumar. It's already 9:15. We are almost.
Sure.
Yep. Okay. Okay, so great team. Let's continue with our session now. We will be start discussing about the Git as a source code management tool. What is source code management and everything we're going to discuss quickly. So we have to do this one. I think Kumar, you must have shared the link for the yesterday recording. A couple of them are saying that they are not able to see the recording. So please do check that accordingly. So Gopal, I think the Kumar will help you offline. So please check with him. You can see in the WhatsApp group, you will get the notifications. But let's continue with our session today right now. Right, so we can continue or we can cover the topics accordingly. So here team, the first topic, as I was still right, yesterday we have completed installing the Git software on our machines, right? We have taken a EC2 instance and we are able to log in, and then we are able to log into the instances accordingly, and we start installing the Git software also. So let me just show you that one more time. So team, here it is, right? I think you can see my screen right now, the Git bash that we just did yesterday. So I logged into my instance today, the same one which we created yesterday. So I just logged in, and then here we already installed the Git software, Git hyphen version. You can see that we already installed some Git software. So we're going to work on this Git software itself yesterday, whatever we installed it. But before we get into it, we need to understand what exactly is your what exactly is your Git, why do we need Git, and all that stuff. So let me give a quick background of what is Git and why do we need it. So we will think about this team. Just give me a second. Yeah, so let's do here. As all of you can see my screen, I just draw little diagrams here just to make you understand what exactly are the things. So team, here try to understand, Git is called as a version control system or a source code management tool. So when we say source code management or version control system specifically, what exactly is the version, right? When I say version, team, a version means that, I hope you guys are all using Android or iOS. Whenever you see that some iOS version is getting upgraded, or you might get updates for the iOS versions, right? So whenever you release a software team into the market, so we always maintain a version number for it. Why do we maintain the version number? Is to keep track of changes, right? Means that, let's say that iOS 10 was released and later iOS 11 was released, then we have iOS 13 right now. So in order to track the changes between the versions, we need to some kind of a system which helps us track these changes, so that in case of any issues with the latest version, we can quickly roll back to the previous version and we can enable the the version which is working fine. Absolutely right. Now that is the reason, team, we must maintain a version, or we must make sure that whatever the changes that you are doing to a software or a piece of code, right, need to be tracked. Let's say that even if you update a single line or a single word in your source code, it must be tracked what exactly was the change made and why the change was made. Now introducing that new change may harm something or may cause some issues here to application, right? So in case of an issue, we need to have a way to get back to that previous position, so that we will be able to having working software always in our hands. Now that is the purpose of version, team, in simple words we call it. So there are, we do maintain a different numbers at the version level, like 13 dot, let's take iOS current version, which is resembles like 13.0.2, something like that. Now, why do we maintain these many digits instead of maintaining a single iOS 13 version, right? I'm not sure how many of you looked at the iOS version right now. When you go and check the version number, it is not just the 13, but it just says that 13.0.2. Something like that, right? There is some kind of numbers out there. Now, what exactly is the purpose of these numbers? If you look at it, now, based on this one, team, basically we look at, or we say that the effect or the impact on the application, the changes that you are making will reflect these versions actually, or these numbers basically. Now, if you look at this, team, as per my screen here, let's say that 13.1.4, or let's say that there are three numbers. The last number is always called as a bug fix or a defect, we call it. Let's say that you're using the iOS 13 dot something, but you as an end user, you had some problem and fixing some issue, then you sent a report back to the iOS or Apple. Basically they fixed it. It's a simple bug basically. So they are releasing the newly fixed code, so they are changing, or whenever they release a simple bug basically, they will change the last number, which is called as hot fix. When I say hot fix, team, it is like kind of a small issue which need to be fixed immediately. We worked with the company has provided a solution for us, and they released a new version or new change to the working software. The change will be tracked with that particular number. The last number changes, it is a small change, team. That's what you need to understand. Now instead of a last number, it gets the change, the second one, like the 13.1 getting changed here, which means that it is also known as a minor change. When we talk about a minor change, basically the minor change refers to multiple defects, like multiple issues need to be fixed. Along with that, there might be a new feature gets added to your software, right? Think about that. Whenever you get a new update, they will say that so and so security bug is fixed, and along with that, we are also releasing the latest iOS feature, this one, so and so. So this can be called as your minor change to the software, which introduces a couple of changes, not a single change, but a couple of changes, maybe a new feature or maybe a multiple defects which were reported earlier with the earlier versions. Those are all fixed out, and they will release a new version with a changing called as the second digit, which is can be one, can be changed to two accordingly. That is what is called as minor change, right? And finally, team, if you're facelifting your application completely, like you added n number of new features and completely changing the design of the software and everything completely, a look and feel of the software, then you may release that as a new version completely. Instead of 13, we call it as 14 now, or whatever it may be. That is how it is be taken care, right? This is how, team, we actually maintain the versioning of the software. Now at the end of the day, the purpose is very simple. In order to track the changes, whenever we keep on making the changes, in order to track the changes, we keep on updating our versions in the system. That is what is called as versioning basically. Now team, if I make a couple of changes, that's okay, great, we can see at that one. But if I keep on making changes, let's say that multiple developers are working on the source code and multiple changes are coming out, it is hard for me to track the changes. Now that is where instead of you tracking the changes manually, we're going to use a tool, right? A tool is nothing but called as a version control system, which means that you simply start writing the code or you simply start doing your own changes, whatever you want to do it. But in the back end, the version control system tool is going to track your changes. That is what all we need to understand here, right? This is how you can think about it. How do we track the changes? We have to use a tool so that it will be easy for me to track the changes, and the tool also help me to simply get back to a previous version with a single commands or something like that. That is what it is going to happen. Now this is simply called as a version control system, or why do we need the version control system tools team? So, and Git is also called as a version control system. That is the reason we are talking about these things accordingly. Now team, if I talk about various types of version control system, like we discussed yesterday, over the years we are keep on changing the tools and tech tool set or whatever we're using it. Like we changed from the waterfall to agile to now DevOps. Similarly, that set of tools also we have been improvising on it. We keep on changing the tools also to adopt with the current technology or current DevOps model. The latest tool sets are available just to work faster. We need to work faster. That is what it is, and it will help us deliver the applications also faster. That is where we are trying to adopt the new tools, right? Now over the years team, if you try to think about it, over the years we had various types of version control system. Right now we are using Git is known as the distributed version control system. If you want to understand the distributed version control system, we need to understand what were the previous versions we have it. The first and foremost type of a version control we used to use called as a local version control system. The first one, which you see it, a single box, that is called as local version control system. When I say local version control system team, it is that, let's say that there is a developer is there. Developer installs a tool on his machine to track the changes. So developer machine is the one where it is all the versions, all the software changes have been tracked. Now that is called as local version control system. Ensuring that it can be a developer's laptop or developer desktop, whatever it may be, where developer is writing the code. That is what it is. Now we used to use this one team, but this is not a big help for maintaining the changes. There are a couple of issues here if you think about it. What happens if my developer laptop is crashed, right? Laptops are tend to crash. Our laptop system may crash it because of some issues. So if it happens, basically I will lose all the versions which I'm maintaining so far. I need to start fresh again. Now that again is a big problem for me to track the changes. That's how it is becoming, right? That is the first biggest problem we have with the local version control system. And the second problem with the local version control system is that, let's say that in my project, there are multiple developers are working. Let's say the developer one has his own local version control system. Developer two has his own local version control system. Now, whenever these guys are working parallelly, this guy maintaining his own version, developer one is maintaining his own version. Now, at the end of the day, team, they are working towards a single project or single application code. Now, when you want to collaborate between these one, I need to maintain the version as a single unit again. Now, how do I collaborate between the developers to maintain a constant versioning again? Now, that's also a big problem with the local version control system. That is the reason we taken out here, and we moved on to a second type of a version control system, which helps us, or which was helping us over a decade for maintaining the versions very properly, which is called as centralized version control system. Okay, so when I say centralized version control system here team, right, when we say centralized version control system, right, we have a centralized server. Think about team, it's kind of a Google Drive, right? You might know the Google Drive, right? You have a Google Drive, and I upload something there, and if I want to share with everybody, I can share a simple link so that everybody able to view the content. Or if I give the edit permissions also, they will be able to edit the content on the Google Drive. Kind of a centralized server you have it, where we maintain the source code completely, and then we ask multiple developers to connect to that centralized server where exactly the versions are maintained. Look at this one team. In a centralized version control system, there is a repository on the centralized server. That server being connected by the developer one or developer two, they will connect to the same repository, and they make a copy to the local. Of course, they will have to work on the locals. They will make a copy of the centralized repository onto the local, and they will start working on it. But whenever they want to commit, or whenever they want to create a version for the change they did it, they have to push the changes into the centralized version control system. Now, whenever you upload the changes, or whenever you push the changes into the centralized version control system, The centralized version control system will create a new version for the change you uploaded and will keep on tracking the changes accordingly. Now this way team, the multiple developers can connect to the same repository. They keep on making the changes. Everybody can create a new version. Whatever may be the things you are making it, everything for every commit or every push, it is going to create a new version accordingly. All the versions are being maintained centrally, so it is becoming very easy for me to collaborate within multiple people, and it is available centrally also. People can look at one location for the entire source code. That is something you need to have an idea, right? Now this is centralized version control system team. It was working very well, but what exactly is the problem with centralized version control system? I think you might have aware of the tools called as subversion or SVN or CVS. These are all called as centralized version control systems. So there are many examples, there are many tools as such. Basically we're using it so far. Now with a centralized version control system team, it was absolutely working fine, but we were looking for more benefits. We wanted to be much faster, maintaining the versions and getting back to the changes accordingly. So here team, there are two problems with centralized version control system. Again, one thing is called as, if my centralized server is gone, all the developers will sit idle. They will not be able to make any changes, or if they make also, they will not be able to create a new version for it. So we are dependent on the centralized server to create the versions. That is one problem we have it. Now, of course, we are dependent on the network here to make some changes. If my network is not working fine, then that is also becomes a problem. That is what it is, right? So this is how team centralized was good, but we're still looking for much better solution where we can work more robust way and more faster way. That is what we are actually looking for it. Okay, so this is what it is about it. So simply, this is the centralized version control system. This is how we used to work with the centralized versions. In a centralized version control system team, all the versions are maintained at the centralized server only. Assume that that is it. Now here at the end, right, we have now in a current world, in a DevOps world, basically, where we are talking about something called as distributed version control system. Now Git is called as a distributed version control system, which helps us maintain the versions of the source code at a different location or multiple distributed, right? Now let's say that team developer one is it's similar to the centralized architecture only. We will have a centralized server, just like the Google Drive. Think about it. We still have to upload the changes into a centralized server to collaborate between multiple people. That is absolutely there, right? Now that is the first thing. So you have a centralized server here. In the centralized server, you create a repository. In the centralized server, you will have all the versions maintained for the source code. Whatever the changes you've been taking or whatever the changes you've been making to the source code, everything will be tracked by the Git in the centralized server. That is one thing you can think about it. But along with that, there is a developer machine. Like developer machine also will track it, because we're going to install a client on the developer machine, which is called as a Git client. Now whenever the developer gets the changes from the centralized server, he is not just getting the source code, but he is also copying the versioning. Whatever the change, versioning, version tracking, everything will be copied into the local machine. That is one thing we have it, so that we have the versions maintained at the centralized server, like v1, v2, v3, and the same version will be copied out to the developer one machine or developer two machine. Whoever makes a copy from the centralized server, all will be available across multiple systems. Now this is why it is called as distributed version control system, right? What happens if my centralized version control system gone? I still have the versions in my local, right? I can still upload it back to the centralized server once it is online. What happens if centralized is gone, developer one is gone? I still have a copy with developer two. So I can keep on, there's much less chances that you will lose your version tracking. That is the biggest advantage that you have with the distributed version control system. And the second thing is about, whenever you are making a change in the source code, you work in your local desktop or laptop, developer works on their own desktops. So whenever they commit or whenever they want to save the changes, everything will be saved in the local system itself, which is like a hybrid team. Think about it. In the centralized, we have a centralized version system. In the local, we had a local. So we combined these two into a single thing. Now that is called as distributed, or it is a hybrid model. You have the versions in the local as well as in the centralized server. So it is a combination of your local version control system plus a centralized version control system. So this way we are able to maintain the versions across multiple systems, and saving the changes, or whenever you want to make a version change, you can simply commit everything in the local itself. Once you are done with the changes completely in the local, you can just upload them to the centralized server. So that way it will be easy for me to, no need of dependency on the network to create versions and all that stuff. This way it will be easy for me to make the changes and keep track of changes at both locations also. Now that is the one team we have called it as distributed version control system. Accordingly, we are going to work on this itself now. Assume that we're going to work on this one itself. Team, yesterday we installed something called as a Git software on our EC2 instance or AWS Ubuntu machine. Consider that that is a developer machine where the developer will be working on the source code completely. Yesterday team, as I say, like this is the machine. Consider this is your AWS Ubuntu system, right? So where we installed our thing, so we're going to install Git client, right? That is what we installed yesterday. Git client is what we installed on our Ubuntu instance. Now we're going to keep track of changes, or we're going to make the changes in my local itself by creating a repository and everything. Now if you're thinking that what could be my centralized server here, the centralized server or centralized thing we're going to use of public repository, which is called as GitHub. I hope everybody might be aware of GitHub team. So GitHub is a centralized version control system tool. We have it. So you could create an account here, whatever you wanted. Simply create an account. I logged into my one. Let me show you. So here it is, team. You can sign up for this one. This is a public repository. Basically, it is a free account completely. You can just simply create your account and you can start uploading your changes into the centralized server. You can, whatever you want to do it, update it or look at it, whatever you want to do it, you can do it accordingly. Now this is what is called as your centralized server team. In this way, in our today's session, we're going to work on local first of all, where we're going to work or make the changes in the local completely. We can create multiple changes or track the changes in the local completely by using Git. And completely once it is done, we're going to simply upload the changes into the centralized server by creating a repository also. So we'll keep connecting in the centralized as well as local. We will be making the changes accordingly. Now this is what is called as your distributed version control system team, with which we're going to work on today. So let me show you that. Git is a client basically in which where the local developer works on it. GitHub is kind of a Google Drive, right? GitHub is kind of a Google Drive where you can upload the changes and share with everybody. It's a public repository, so you can upload and share it with everybody, whatever you want. Whereas your Git is local client, it will help you track the changes in your local system accordingly. That is what is the difference between your GitHub and then Git client. Okay. So here it is, team. So by saying that one, now I'm getting back to my instance here. So where we can start working. As I said, like this could be your developer machine. Think about this one, right? You have the Git here and everything is good. That's okay. Now here, team, once you have the developer machine or once you have it ready, so how do I track my changes? How does the developer, means that team, as a developer now, I need to start writing the code. We're not going to really write the code, but I'm just going to make some dummy code. We can see that accordingly, how Git is going to help us tracking the changes on my system. Assume that this is a developer machine. I'm a developer right now. I'm going to write some code. So when I'm writing the code, when I see that how Git is going to track the changes in my local system, that is what we're going to understand right now. So by default, team, we already installed the Git. That is what we did it yesterday. So let me show you that again. So Git version, we have a Git is responding for us, so which means that Git is available. Now before you make any changes, team, right, Git is a software basically, so you must inform Git who you are so that Git can track the changes based on your name itself. I know you logged into your system, but Git really does not know. It may think that your name is root because you're working as a root user right now. It may think that your name is root, right? So it's going to track the changes with root. Instead of that one, we must tell Git that who you are, means that we are going to configure the Git now with our username or email, whatever it may be, so that Git can track the changes on my name itself. This will be helpful, team, when multiple people are working towards the same project, same application code and everything, multiple modules maybe. Now whoever did what, who did what, basically will be tracked by the Git. If I make some changes, Git will track the changes on my name. If my colleague makes the changes to a file or source code, that Git on his system will track it with this name, so that whenever somebody looks at it, people understand, okay, this change made by the developer 2, this change made by the developer 1. That is how people can understand it. That is the reason, team, we need to configure the Git on our local system. The commands we can show now is this one, git config we call it, and hyphen global. These are the syntax team. I'll share all these commands, so do not worry, just follow me what I'm just doing it. Okay, so get config hyphen global. Once this is done, we can see that user dot name I'm giving it, and this is the syntax of get team. I'm not writing on my own. When you learn the tool, there are pre syntaxes will be given to you, just you need to follow them accordingly. I'm just saying that this is my name, learn DevOps, whatever it is, and let's say that get config hyphen global user dot email. I'm just going to mention my email also, just for tracking the changes account. So this is what is my email actually. So I configured get. Now if I want to see the configuration which I did, we can say that get config hyphen list. So it should show you your name, user.name and user.email which you configured. That is what all it is going to show you. Once you configure this one, now we need to ask Git to track the changes. But what exactly the changes we're going to track, right? Assume that team, if you are working on a project, basically, we always work project folder, or we create a project folder basically, and we start putting our code into a single directory, right? It is not that we're going to spread across multiple directories. It is a single directory always. So let me create a directory. Let's say that mkdir, let's say that this is my code, is what I'm saying, that my project or my code, whatever it may be. I'm just creating a folder here. Now I'm going inside this particular folder. Now I want Git to track the changes, whatever I do it in this particular directory. I don't want to spread across my system completely, but I want Git to track the changes only in this particular thing. So what exactly Git tells you is that we need to initialize the repository. Means the local repository, we call it. Repository is nothing but where you save the source code and everything always. So here team, in this folder, we're going to initialize the Git repository. So in order to initialize a Git repository, we simply run a command called as git init, right? If I say git init here, it says that initialize the empty Git repository, so on so folder. That is what it is telling you. We can see that. Now, as of now, team, in this folder, there is nothing, that nothing is available. We haven't done any changes to the source code or anything we did it. Now we can start writing something in this folder. Now, as soon as I start writing it, Git will start tracking the changes, or Git will help you track the changes. You can work on your own work. You start making the changes. Once you're done with the changes, you can simply tell Git that, okay, save this change, make a version for it, and then we're going to complete with that. This is what all we're going to do it. So just let me show you first of all, in order to check the current status of the repository, what exactly we're doing it, there is a command called as git status. Now this command must be run inside a git repository team. Right now my code folder is nothing but my git repository. Whenever you type any git related command, please do type it inside the repository folder always, so that git can respond to you accordingly inside this particular repository only. Okay, so this is what all about it. Now let's now see that there are no commits, or no commits in the sense team, no versions yet. That is what it is telling you. There is nothing I have done so far in my repository. It says that it is an empty repository, so you have to work on the things accordingly. Now in order to work on the things team, whether, think about it team, any change that you do to a system right now, any change that you do inside this directory, which can be creating a file or deleting a file or modifying a file, because when I say I'm writing a source code, I wrote the files only, right? It can be HTML or Java code or whatever it may be. End of the day, it is going to be a file, right? So the file can be deleted, or file can be created, or file can be modified. These are the only things that we do it mostly. So let's say that I'm going to create a file because it's an empty repository right now. Let me create a file which is going to be, let's say that touch new .java file which I'm creating it. That is like, assume that I'm going to write the Java code, right? Now team, I just created a file here. You can see that the file is available. Now as soon as I created a file, we can see that git status one more time. Now you can see the git difference earlier on. Now here Git is telling you that, okay, there is something happened in this repository which is untracked file. Means that Git is telling you that you did something, it is still untracked. If you want me to track it, now you need to inform me what exactly is this by adding a Git file. So this is what Git tells team. Now we need to do something called as git add. We are just informing the Git by saying git add the file name new.file or new.java. Now, whenever I say this one, okay, Git understands what exactly you did it. Now, if I say git status one more time, it says that, okay, you created a new file. I understand that you created a new file now. Okay, good. If you want me to create a version for it, now you need to commit it. Committing is nothing but creating a version in the repository. That's what we call it. Don't think like team, it is creating the versions v1, v2 like that. It is going to be a long commit ID, we call it. But let me show you how does it look like, right? Let's say that git commit is a command -m. Let's say that my first commit, whatever it is, you have to mention it. You can mention a random message also here, team, that's fine. But this is how it is going to be done. So let's create this one. Now it is completed. Let's say that git log. Now let's git status. I'll do it one more time. Now it will tell you that, okay, on branch master, nothing to commit again, which means that git is telling you, okay, whatever is there in the repository, I already know it. There is nothing new you have added. If there is any change again, I will let you know the things accordingly. Now team, very carefully understand thing. Git follows something called as three-step process. Okay, git follows something called as three-step process. Basically, there is something called as step one, make changes in git repository, right? This is the first step. Making the changes is nothing but create a file or delete a file or modify a file, whatever you do it. This is what is called as your making changes. Now once you have made the changes, whatever it may be, second thing is that stage the changes. Technical term I'm using it, stage the changes. Staging the changes means that team letting git know that what exactly, whether you modified a file or whether you deleted a file, what change you have made it compared to the previous version. So git is going to understand that changes. Okay, previously this was the one. Now if you tell it, then only git understands, otherwise git does not understand. It's going to tell you that, okay, you made some changes, but please do let me know what exactly you did it. So that is called as staging. This is here we call it as git add, right? Git add is a command, we can use it, and then the file name, whatever you do it, or you can give a dot also to make the add all the current changes accordingly. Now the third thing, team, very important, this is a three-step process completely. Let's say that I modified a file, I deleted a file, and I created a new file. These are the three changes I made it, and for these three changes I informed git that I did three changes also. Finally, for these three changes together, if I want to commit or create a version for it, I can simply create a version of it, commit the changes. Whenever you completed the changes, team, it is not that for every single change you have to commit it. It's not like that. You can make 100 changes also, and you can let git know that whatever the changes you made it, then you can commit them once also. That is how you can do it. Commit the changes. Now that is what we call it as git commit and a message, whatever you do it. This is the three-step process, team. No matter what, whatever you do it, every time you did it, you have to git add and git commit. Or whenever you want to commit it, you can add git for everything, but you can add things accordingly. Now let me show you, team, the couple of things again. We just did one change so far, and we created one thing only. Here, let's say that I'm going to create multiple files right now. Let's say that 1.java and 2.c file and 3.xml file. So I'm creating multiple files basically. Okay, this is what all I'm doing it. Now there are few files available for me like this. Source code can be combination of any file system. It's not that always the Java files will be there. Now let's say that git status one more time. I can see that it's still said, okay, the new file new.java, I already know there is nothing happened to it, but there are three new files, I got it accordingly, right? Now this is how you can do it. Now in order to modify the new.java, team, let's say that I'm doing an echo. Hi there. I'm just appending some text into my new.java. That is what I'm doing it. This is, I just modified the file right now. I'm not doing this on team, just modifying the file. I'm appending this content to the file. Let's say that cat new.java here. The inside the file, now I have the content like this. So if I say now git status, right, try to understand it. Now it says that, okay, you modified this file, because I already know this file. I understand that you modified the file. That is what I'm telling you. But still I don't know what exactly you did there, what exactly you modified, changes. Still you need to do it accordingly. Now there are new files which I don't know yet about them. If you want to let me know about them, you do the git add again. For both of the changes, team, we need to do the git add compulsory. So let's say that git add. You can give a single file name like this, team, or if I want to add all the changes at once, whatever I did it, I can simply say dot in my current directory, which means that in my current project, whatever the changes I did so far, I simply would like to commit them or let git know them. That's what I'm doing it. If I say git add dot, that will be there, and git status, there are 4 files that are added right now. Now simply commit them if you would like to. Commit -m, right? Second commit This would be the generic information team. Let's say that I'm working towards a defect or I'm working towards a feature of the application. Then there would be something called as feature IDs or feature names. We'll mention it accordingly to make them understand. Right now, I'm just doing to make you understand that we are creating a second version, which is nothing but your second commit. Now, team, there are two changes we saved in the repository right now, which is called as two commits we did it. Commit is nothing but a saving. Every commit can be referred as a version number for, changes that you did to the repository, right? It is all about changes you want to track it. So every commit refers to a change in the repository. So that is how you can keep track the changes, or Git is tracking the changes actually. And then you can simply look at whatever you did so far. Git log is a command to check the history of the changes you made it. Nothing but the commit IDs, it will be showing up to you. Now there are two changes you made it, means the two times you modified and you let Git know that what exactly the changes you did it. This is how, team, you can say that there is a first commit ID and the second commit ID. This is can be considered as your version, or in simple words we call them as changes tracked by the Git accordingly. Changes tracked by the Git are showing the commit IDs. Now if I want to know what exactly I did in this particular change, particular this version exactly here, there is a simple command called as git show, like this. So you can see that there are multiple changes. It says that there's a new file you created. This is a new file. This is a new file basically, and this is also something new file. This is also new file, and there is something called as this is modified something, right? This is how you can do it. If you would like to look at that, team, basically I think we can use a git show -p command and new.java, right? You can see that what exactly was the change made to this particular thing also. So this is what it is showing you accordingly. So if you make big changes, it will show up to you. You can look for a particular file change also, what exactly was the change made to that particular file, using a git show -p command accordingly, right? Now likewise, team, we have multiple commands to track the changes. Like you see that there's a basic process that we followed it. Now after this one, you did something like this, new.java, everything is taken care. So if you want to look at the changes happen to a file, you can use something like this, git show -p and all the commands accordingly, right? So we learned about now git init command, git add command, git status command, and git commit command. Along with that, git show command also we see it, and git log command to track the changes accordingly. We will cover that also permanently. Just hold on for some time. Okay. So here it is. Now this is the basic stuff that we did it actually right now in our local machine, right? Whatever the changes we are doing it, everything is in the local itself. Local means that it is local to the developer. Only developer one can see these changes in his system. That's all about it. Now let's assume, team, here, this is what is happening here. Let me show you a couple of more things here. In this one, there is something called as, I would like to discuss something called as a git ignore command or git ignore file in your repository. We'll cover that git ignore file and we'll jump on to the next topic. Let's try to understand, team. Let's say that, assume that you are written a program. Let's say in your graduation, you may have written a program, let's see program or something. Whenever you write a program, you quickly execute it, right? Means that you run the program to check whether the program is working or not. In such cases, team, where it is generating the output, you might see the output in the console file accordingly. That is what you see it normally, the output of the program, whatever you written. Now in general, team, like this one, these outputs may generate some send of random files also, output files accordingly. So those output files, team, not the actual source code. Or let's say that I'm keeping some information for my repository. I'm learning some new things, so I'm just going to keep my information here itself. So whatever it is, team, apart from the source code, actual source code, we should not be tracking any changes. In simple words, I'll tell you how to tell Git that to avoid some files, because whatever the changes I'm making in my repository, Git is going to track it, but I want to let Git avoid some files purposefully. So how do I do that? Right now, that is where, team, we introduce something called as git ignore. Git ignore is a file here. The syntax goes like that. First of all, you need to create a file called as dot git ignore. Okay, this is a file starts with the dot, team. It is a mandatory syntax. The file name is here like this, git ignore. Dot git ignore is the file name. Now this file basically is used to mention the file names which you want to avoid it, right? Right now, let's say that here I'll open the file, team, for editing. Just say that git ignore is a file I'm opening for editing it. Now inside this file, basically I'm mentioning a couple of files, and let's say that naresh.info file. It's my information about my learnings and everything I'm doing it. Now, along with that, I can also say that any file that ends with a log means that we can use the wild characters here. Let's say that the file name can be anything, but if it is ending with a .log extension, I want to avoid that file. I should not be tracking that, or my Git should not track the changes accordingly. This is one thing, right? Here it is. Once this is done, right? Let's say that we can have a folder also. Let's say that there is a folder called as test folder. I have it, some testing purpose I'm using it. The entire folder I want to avoid it. Let's say that this is the folder syntax, and likewise team, you can mention in this file whatever the things that you want to avoid it. Now let's say that team, this is the file which I want to avoid it. Let's say that I created the file already. So as soon as the git ignore is created team, it starts to get into the action. Now if you see this git status, right, you can see that simply git ignore is available. It is still untracked by the whatever it is, right? But if I create a file team, earlier we saw that if I create a file, git says that that is also there. But in this case, if I say git naresh.info and I ask this file to be avoided by the git, let's see that if it is going to avoid or not, right? Let's say that I created the file right now. The file is available in my repository, but does git is tracking that changes? Git status, git is not even looking at that file. You can see that file was created as per the one. Whenever you create a new file, it is going to say that untracked file, but still it is not telling you because that file was mentioned inside the git ignore. Git is simply avoiding that file, whatever it may be. Similarly team, we have another file here which is going to be your uh, you know any log file, right? We say that star.log file. Let's say that touch new .log file. I'm creating it, right? Hello.log, whatever the number of files which are extended with .log, which is going to be avoided. ls-l, you see that there are two log files available, but does my git track them again? No, git is not at all tracking them. You can see that git is not even worried about that files. So you created, it just avoided that things accordingly. Similarly, we also created a folder. Let's create a folder also, mkdir test. Inside this folder team, whatever is inside this folder is going to avoid it. So I didn't say that not to ignore the Java file. Let's say that I'm saying that abc.java, right? I did not ask to ignore the Java file, but I asked to ignore the directory, right? Here I asked to ignore the complete directory itself. So whatever is inside the directory, whether it is a Java file or a C file or XML file, it is going to avoid it completely. Let's say that git status, it does not track that folder also. Git ignore is something team, in order to avoid something in your repository by tracking by the git, we simply use git ignore actually. So this is what all you can understand. Now git ignore is also changed to the repository system. We need to consider that as a change. We need to add and commit git add dot, and let's see that git commit -m added git ignore. This is what is the message I'm giving it, right? So this commit refers to the git ignore changes. So I'm just doing this one. Now finally you added this one, git log again. Now you can see that team git log output shows the commit ID again, the latest commit ID, and author who did the change basically, and when this was committed and what is the change about. All these things will be shown to you in the history. That is the reason we configured our username and email before we start working on the things accordingly. Now assume that team, this is all the changes, or this is the changes that the developer will be doing on his local all the time completely. Whatever he do it, he always works on the local. These changes or these kind of changes means he start writing the code, source code, Java programming, whatever he wants to write it, he keep on writing the changes. Whenever he feels that everything is good, if he wants to create a version, everything will be created in his local only. There is no dependency with the centralized server here. Now assume that team, now we are done with the changes here. Now I want to share this with multiple people or give it to the centralized repository so that multiple people can look at this code accordingly. Now what I'll do is, or we need to create an account. As I said, you have to create an account in this GitHub. So we're going to create, or we're going to upload the changes to the centralized repository. Now let's say that I'm going to sign in team because I already have an account. My account is lead DevOps. This is how I logged in here right now. You may not see like this thing because I have multiple projects here already running, so this will be there. You might see an empty page, whatever it may be, but we have to create a repository here again, like you created in the local using a git init command. Here also we need to create a new repository so that we can link the both of them accordingly. Okay, so here it is team, on the top right corner where you see it, there is a plus symbol available in which you will find something called as a new repository, right? This is where I'm just registering something called as, let's say that my code one. I'm just giving the repository name as my code one because my code is already existing, I believe, in my thing. So it is saying that it is already used. So let's say that my code one, I'm giving it the repository name, which is going to work, right? And this is a public repository again, that's okay. And simply say that create repository, okay? This is what all I'm doing it, creating a repository right now on the centralized server, like you did in the command line. That is nothing but your local machine, but this is a centralized server where everybody else can see it accordingly. Now here it is team, this is what the changes which I have it, right? So here it is, there are two things it is suggesting. Basically create a new repository on the command line. I think git init and everything, we did all these things in the local already, since we are avoiding this option, or push an existing repository into the command line from the command line, right? So what exactly we are doing here team, again let me show you that in simple words, right? So here it is. So far, as I said, like we were working on my machine, let's say that the developer machine, consider that I'm a developer one, right? Developer one machine where I have a repository called as my code, where I had three commits, commit one, commit two, commit three, like that. Whatever I did it, I have done these changes, right? Now team, I'm trying to change, or I would like to save, or I would like to share the details with you all. Now what I'll do is simply I will create a repository here also, whatever the name doesn't matter. Let's say that here I created this one. Now this is what is called as your GitHub team. GitHub is something using simply here to create the centralized repository. Now what exactly we do is we need to connect these two repositories first of all, right? Connect them means that since this is a local, this is a remote, my local does not know where is the remote yet. So that is where here, in order to connect the local repository and the remote repository, sorry, here, right? Now this is what I'm calling team. This is called as your local repo, right? And this is called as your remote repo. Remote in the sense the centralized repo, whatever you call it. This is what it is called as remote repository. You have it. Now in order to add this team, that is where this is suggesting you a command. It says that git remote add. This is the one we need to write on the command line. What I'm telling my local repository is that right here in my local repository, I'm adding the remote repository here. This is my remote repository address, which is https github.com lead DevOps and so on. So, and I'm adding that report and creating an alias name called as origin. This is all I'm doing it here, just adding it. Now, if you want to check it, git remote -v. Now, this is what it is. By running this command, basically, we just attached my local repository to the centralized repository accordingly. This is what all we did it. Okay. This is what all we did it so far. Now, how do I upload the changes team? The operation here is called as push. Okay. Push is the operation here. That is what we are actually doing it. So you just have to simply upload whatever the changes you did it along with the versions, everything into the centralized repository. That operation is called as push. So what I'm going to simply say command here is called as get push, and where exactly I'm pushing team. -u is nothing but upstream. Origin is the one. It's instead of providing this URL every time, I created an alias for this one called as origin. So I'm saying that upstream origin, and there is something called as master team. We not talk about some, but mastering is called as a branching here. We're gonna see that the default branch is always master branch or master folder. You can think about it. That is what all about it. Let's say that git push -u origin. So here team, it is actually going to ask you the credentials for the GitHub. Let's enter it. It's a lead DevOps, whatever you have it, and the password, whatever you do it. So as soon as you done this one team, you enter your credentials here. It is going to push everything into the centralized repository. Look at this team, whatever I had it in my local, except the git ignore files like log and narration for everything should be uploaded to the centralized repository here. So here it is. Now we have this much. Now you can see that whatever we had in the local, everything is available right now for you all. If you want to access this repository and look at this team, look at this one. I'm sending the link for you guys, all of you. So just access the URL in your browsers now. You should be able to see the content accordingly because I uploaded it. Everything is available for me. It is not only about updating or the syncs team, it is also going to show every commit IDs here. All the commits will be available here, whatever you did it so far. Look at this here. There are 3 commits available. Look at the commit IDs. There are three commit: added, git ignore, second commit, and first commit. Everything will be available. Means that the commit changes are available. It is showing the short form team. If you want to check this one, click on this one. Here it shows the long commit ID, whatever you had it, and whatever the changes we made it with that particular change, everything you can see it very clearly, right? Now these operations are called as uploading team. That is nothing but a git push operation, we call it. So whenever you are ready to push the changes, whenever you're ready to make the changes, or whenever you're ready to collaborate with your team, whatever the changes you made it, you must upload the changes into the centralized server so that everybody else can see that. Similarly, if there is a developer who is working, he can also upload to the same repository again. Collaboration between multiple developers can be done accordingly, so everyone will be able to see that accordingly, right? This is how the collaboration can be done with the multiple team members, and it is easy to track the changes in the centralized server as well as in my local server accordingly. Now this operation is called as git push team. Yes, please go ahead and then tell me. So this is what it is, right? Git push operation in simple words. We did it so far. Okay. So this is all about a team. How exactly we're gonna do it? This is one thing, one way you're doing it basically. Now the second thing is about. Now the second thing is about here. Let's assume that so far I am the only one working here. Let's say that there's a new team member has joined my team, right? Let's say that there's a new team member has joined my team. This guy is called as developer 2, right? This is what it is. Need not to have an SSH here. It's just the HTTPS protocol only, Rohit. No need of SSH. Okay. There are multiple ways to connect to the Git. One of the ways by default HTTPS, that is good enough for us. SSH is another way to connect to Git, but that is not mandatory. HTTPS is good enough for you. Like you see that I did not use SSH here. That is one of the way to do it, but it is not mandatory. Okay, here it is. Now, considering team, getting back to this one, let's assume that there is a developer 2 has joined my team. Now, since this is a guy, we already have the repository here. Now, what exactly this guy has to do it, right? Now, this guy team, first of all, he should make a copy of the centralized repository, right? Because the source code on the part of his joining the team, basically, he may need not to start from the scratch. So he just have to get the repository from the centralized system and he need to copy to the local. Assume that he also installed the git software in his local. Obviously that need to be there. So git software he installed on his machine. Now in order to get the things done or to get the things from the centralized repository to the local machine, right, we call that operation as git clone. Okay, git clone is the operation basically. Means that when I say git clone, basically we're gonna get the entire repository from the centralized server into the local server accordingly. That is what is the operation that I'm telling it. That is what all you need to understand. Let's consider this team. Let me show you a quick example of how it is be done. Let's say that this is the code anyway. This is already have it in my system. Let's say that I have a repository called as this one, sample Java app. This is another repository basically. Assume that this repository is not available on my local system. Considering this is a new repository I need to contribute towards. What I'll take is simply, I'll take the URL of this particular project, whatever it may be, centralized one, and simply come to the system, get out of this system because this is another repository. Now here, what I can do is simply git clone this one. Means if it is a new developer team, he would consider the same thing, but here we are taking that just to make you understand what I'm doing is. So git clone, whenever you say team git clone, basically it is simply going to update the things accordingly. Let's say that ls-l, you have it, sample Java app has been cloned here. If I go into this one, sample Java app, now you see that every content which is available in my centralized repository, whatever the content available here, everything got into the thing accordingly. Now this is how team you need to understand about the clone operation. Whenever you want to take the whole copy from the centralized repository into the local repository, that is where we talk about something called as cloning operation, or clone is the first time operation we call it. Whenever you think that you need to get the whole repository, then we say that that is going to be here git clone operation, and this should be the first time operation only first time operation. from the second time onwards, right? Let's consider that this one, right? Now let's consider this one team. Let me go back to our own repository, not to modify this. There is the dummy project that we just created, which is nothing but your my code one something. Now here team assume, okay, because I don't have another system ready here. So I'm just assuming that there are some people, or we can modify here also team. We can make the changes here also, create a new file, or you can do anything here. Let's say that as a same thing here, right? uh, I'm making some changes in this repository accordingly. Let's say that some other guy who made the changes to this particular repository accordingly. Let's say that he opened this one.java file, right? Click on this file. Let's say that edit this file by using a pencil symbol at the end. Changes, right? Changes made by other developer. I'm just putting some context team or something like this, right? This is changes made it basically. Now this is the change I'm making it. Similarly, you did there. Here also we can commit the changes, provided you need to have the permissions. Until unless you are the owner of the project, you will have all the permissions. Now consider that team. I have modified one.java here, right? But this content, whatever I modified it, does it have it in my local? Let's say that I'm getting back here. This is the repository, right? My code. Now here is what I have one.java, whatever it is. Now team, look at this one. If I open this file one.java, the content is empty because it's just a simple file, basically simple file. Now where we are actually looking for this one, here it is. Sorry, here it is, right? Now this content is not available. Now what should I do here? Do I need to clone the repository one more time to get the changes from the centralized repository to the local repository? Is there any other operation we have it? Now this is where team we actually do something called as, first of all, git fetch, right? Let's say that if there are any differences between your local repository, I just want to know that if there is something has been modified in the centralized repository. Let's say that git fetch is a repository I'm doing it. Now let's say that whenever I say it, it is fetching the changes from the centralized repository. It's saying that, okay, this is your local master, this is the commit ID, you have it. On the origin master, origin is something your centralized server, right? So there you have something different. That's what it is just telling it. Git fetch just shows this difference. Okay, there is something available in the centralized which is not available in your local machine. That is what all it is telling you, correct? Now that is the reason team. In order to get the changes now, we simply do something called as git pull operation. Git pull is operation is something we get the changes from the centralized server and we merge it with the local server accordingly, right? Now this is what you do it. Whenever I say, it's saying that fast forward one.java, one file got changed. Now if I simply go ahead and change it, there is something called as one.java. You see the content which I did it, changes made by the other developer. It has come up to my local machine and it updated the changes in my local machine accordingly. Now this operation is called as pull operation team. This is how you actually do it. This is what is something we do it. Now this is what it is having it. So this is how you can simply understand about the things accordingly. Just consider that readme, right? What is the readme, Sahil? Readme is about, if you want to tell other people that about your project, just add a readme file. People read that file and try to understand your repository. That is all. Do it. Otherwise it is not a mandatory thing about the thing accordingly. Okay, readme is something like just as some information you want to publish to the other people. When somebody looks at your server or when somebody looks at your repository, what that project is about, what is that you're using it, what is the purpose of this project, you can read about it. Kind of a readme file, just update it and then show the other people that, okay, this is the project about it accordingly. That's all about it. Otherwise it is a good practice to keep the readme file. That's, of course, it always suggests you to keep a readme file to make others understanding about your project, as long as you're keeping it as a public project, because publicly available, many people will be accessing that project. So whenever somebody, a new guy, looks at your project, if you want to tell them, okay, this project is about so and so and this is what we're using this project, if he likes it, he can contribute towards it accordingly. It's a best practice to keep the readme. That's always there. It's up to you whether you want to keep it or not. That is depends on you again. Okay, so this is about the git team. Now try to understand that. So this is all the changes like the developer does it. Basically whenever he makes the changes, he simply commit the changes in the local, he create everything in the local itself completely, whatever the things that are there. Once he assume that whatever the changes he made are something done, and that whatever changes he made, committed everything successfully. Now if he wants to collaborate with other people, or he wants to make it available for the end user, or in order to take that to the further level, we always update to the centralized server. Centralized server is something like github.com, where everybody can see the changes, and if they want to contribute towards it, they can contribute, as long as it's a public project. If it is a private, and then it will be available within your organization only. Okay, means that this is a GitHub is a public team which is publicly available for everybody on the internet. But in your organizations, you may go through something called as a private repository, which could be accessible only for your organization, nobody else accordingly. That is what all about you need to do it. Okay, so this is what is called as about the Git repository stream, how to work with Git repository and all the stuff, right? In the local as well as the centralized server. We can cover more topics of the Git team, but since the time constraint we have with this course timelines and everything, these things. So I would stop here with the Git. I know there are many advanced concepts that need to be discussed, like branching and everything, but that is not up to the content we have it here, the timeline. So that is where you may join the next level program, which is going to be a Git, the DevOps professional course, where we'll be discussing in detail about each and every topic. That's what I would suggest. But for this course, we are going to stop it here with a Git. Just to make you understand like how developer works on his local. Finally, he will save everything into the GitHub. That is what all about it. Now we understood about how to work with the changes in the local, the basic commands, everything, and how exactly we will upload the changes into the centralized server. That is what all we looked at it. And whatever the commands I have typed here, team, so far, everything is available in the Git repository, which I have shared yesterday. All the commands, all the installation steps, everything is available here. I just ping the link one more time there. Please open this link which I'm sharing you right now, that one you're seeing on my screen. In this one, you are having everything here about the Git. So open the Git folder here, you will see it, right? So I have installation instruction, along with that working with Git local. Whatever the commands I have typed so far, everything is available here. Go through this document to get the commands accordingly, right? So this is what all about it. So this is all about it. You have to learn the things accordingly. Okay, so this is all about it, teams. So this is all about it. Pomulati, so you have to understand that. That's okay. So this is about a team. This is, you can go through this one. So with this, I'm gonna stop with the Git, so we can continue with the next topics accordingly, which is going to be the Jenkins and Maven, where we'll try to understand once the source code is available. Now assume that, team, with this understanding, developer has completed his development and he updated everything into the centralized server. Now, with that understanding, what exactly we're going to do with the source code, that is what all we need to understand. Okay, here it is. Let's go with that explanation now. Let me show you the things accordingly. Okay, so here it is, team, the simple thing which I have done it here. Now, team, here what you're seeing on my screen, basically this is what is the next step after the source code is available on the GitHub. Now I have shown you here, team, the first thing is something called as this one, where you see something called as a GitHub, where the source code is available for us. Assume that the developer is completed his development and he say that the source code is available in the master branch or whatever it may be in the centralized server. This is the project name and so on. So now what exactly we're going to do with this particular thing, right? So this is what it is. The question here, team, once the source code is available, for ready to the deployment or ready to deliver to the end user, once the development is completed, what exactly we do or how exactly we deliver this code into the end user. Now that is what all we need to discuss here. Just to make you understand, team, here in a simple words, let's say that you are installing something called as VLC media player in your Windows machine. Do you get the entire source code or do you get a simple executable file, right? Think about that scenario, team. VLC media player is also an application or a software for which also somebody might have written some code along with that completely. Now once the source code or combination is available for that, completely the source code is available, they converted the entire source code into a simple executable file, right? That is what they did, and they gave you the executable file. Now you're able to take that file and you're able to install that onto your Windows machine accordingly. Now, in order to install that applications team, any kind of an thing, basically, in case of a Windows application, you see the something called as .exe. The only thing that we need to understand here is that once the source code is available, once the developer says that the development is over, we need to take that source code and convert that into an executable format. Now that process, we call it as a build code process. Look at this one, team. The next step is that we need to build the code. That is what is something we're going to do. We're going to take a real project, real Java project, and we're going to build that code completely, and we'll see what kind of things we're going to get it accordingly. So means that converting the source code into an executable format such as .exe for, like VLC MW, that's a Windows based applications. Since we're going to work on the Java based applications right now, the extensions will be like .er, .jar or .var file. For the Java based applications, we have it accordingly. So this is what it is, team. So we're going to take the source code and we need to build the code. That is what is the next process. Now, how do I build the code is a question, right? To build the code into an executable files, we use something called as build tools. Build tools are the one, means how do I convert my entire source code, multiple files, into a single zip file or single thing. That is where we use something called as a build tool, such as Maven is a build tool basically, and there are many build tools we have it in the market based on the programming language that you use it. There are multiple build tools will be available, so those things you need to understand accordingly. Okay, so Maven is the build tool for building a Java applications team, the widely used tool in the market. There was something called as Ant also. We never, people used to use it, but they moved on to Maven completely. Now we are working towards the Gradle also. There are many tools available in the market, but Maven being the popular tool so far, we're going to work on the Maven itself. So Maven is a build tool here to convert our source code into the executable format. That is what we're going to do it now, which is good right now, right? We can take the source code and we can convert into an executable file. That is the end goal, right? But the build code process team have a various steps here that is need to be followed as per the standards of a Java development status, or every organization follows something called as build process, right? There are various steps involved in the build code process. While building the code, we need to follow some standards. Like to develop something, we have some standards. In order to build the code also, we have some standards here. So that is where we follow these 5 steps which I'm seeing on my screen right now, which is called as compilation, we call it, and code review, unit test, code coverage, and then finally the package. Now this is the things team that we do it actually. Now what exactly these steps are, why do we need to perform all these steps? If you are having that question, think about this team. Let's say that compilation is something, I hope you know that, right? Whenever we write the program, we write in our own understandable format. Let's say that the Java is a language which I understand it. I use the Java programming language to write the Java code. But does your machine understand the Java language? Is the question, because machine is a hardware, right? Hardware or a processor, basically what does the machine understands is that machine can understand only the binary code, which is nothing but a zeros and ones. Now that is where team, the compilation process here helps us convert the source code into a byte code completely, or a machine understandable format, we call it. The compilation is a mandatory process. Once you have done with your development, convert the entire source code, entire Java code, whatever you have written, into a machine understandable format that we call it as a byte code, zeros and ones, whatever it is. The compilation process helps us converting this one. Most of the people think that compilation is to find the errors. It is not really to find the errors basically, but it is to convert the source code from high level language into a low level language or a machine understandable format accordingly. That is what is the process of compilation. So we must do that, because at the end of the day, this code will be processed by your machine, right? The application that you developed it, we do not deploy it onto a system. The system should understand to process your application or to show you the features of the application accordingly. That is the reason we must compile it. That is the first step. We do it as part of your things accordingly. Now that's one thing accordingly. The second thing is about code review. Now team, as I'm telling it, we can directly go for a compilation and packaging it. The packaging is the last step, as you see it, convert the source code into executable format, right? That is what is the goal of your things next thing. We simply compile it and then package it. This is what I can do simply. There is no question about it. A lot of organization may do that also. But as per the standards, we need to follow some standards to build the code. Before you package itself, are there any issues in my source code? Let's say that developer has written 1,000 lines of a code, but who validated that? Did he miss any braces or kind of a thing? Did he put any spelling mistakes? Or is there anything that he made some mistakes, or did he write the code as per the standards of Java or not? How do we identify those things, right? Now that is where we introduce a few steps here, right? That is where we introduce a few steps, which is called as code review. Code review is something, team. Let's take source code which is written by, let's say that developer has written a Java file. Now I'll go line by line, right? Let's say that this is good, this is good. The line by line code we go with, and we'll ensure that everything is perfect. That is called as review. But here we are not going to do the line by line code review, but there is a tools which are going to help us to review the code and identify the issues accordingly. That is where we're going to integrate that one. The code review tools we use it, such as PMD plugin, we have it, program mistake detector. There are few tools available to perform the code review operations completely. We're going to do it according, that is what we're going to do it. Now similarly we do the unit testing also. Unit testing is something, team, it's a called as a developer level testing. Means that, let's say developer has written a program. As I said like earlier also, whenever you write a program, you simply execute that program to whether it is writing the output correctly or not, right? Now that is the same thing developer going to do it. Since the developer writes many methods or many programs, such programs, to develop the complete application, he going to perform the unit testing, like every method or every program, simple program, a single program, whether it is working and whether it is expected results are coming or not. He is going to test each and every function, each and every method in the source code separately, a unit by unit. That is why it is called as unit testing. That is also may need to be taken care by the developer. You are not going to do it, but your developer will write the test cases for it, and he's going to provide the test cases. So we may run that accordingly. We're going to see that. Now that is something, team, unit testing we call it. Now there's something called as code coverage also. What exactly is code coverage, right? Of course, here, team, try to understand. We're doing the unit testing, right? That's what I just told you. Unit testing is that, let's say that there are 100 methods I have written in my entire source code, 100 functions or whatever it may be, think about it. Now, did my developer test all 100 functions individually, or he tested only 20 of them? How do I know that, right? So that is what is called as code coverage, team. Code coverage is something based on the unit testing, how much unit testing was performed, how many functions he tested, how many methods he tested, how many classes he tested. So these are all the coding techniques we have it. So we just try to identify whether my developer he's doing his duty completely or not. We will cover that, and code coverage is going to show me a results, how much testing was covered as part of the unit testing. That is what it is doing it. Now once we assume all these things are perfectly good, team, once we assume that all these things are perfectly good, then we finally bundle our code for deployment, right? Let's say that we're going to prepare our war file or kind of a packaging file. This is what we're going to do it, and we'll take this war file, can be deployed onto a web server or Tomcat like that. That is what we're going to do it. Okay, now that is what it is, team. Basically we call it the code, the build process code. Who is doing all this task, team? As I tell, like build tool is the one which is going to do all these things. Like Maven is a build tool here. Maven is used to perform this one. Let's say that I'll ask Maven to compile it. Maven going to compile the source code completely, convert that into a bytecode format. Maven is a build tool here which is going to perform all these steps accordingly, right? That is what it is. So Maven can review the code, Maven can unit test the code based on the test cases given, Maven can do the code coverage, and finally Maven is the one which is building the source code completely, which is converting the source code into an executable format. That is the duty of your Maven tool, right? That is what we can do it now, which is fantastic. Maven is a tool which is helping me with all, but where does the Jenkins comes into the picture? Because we wanted to discuss the Jenkins also, right? Jenkins is the topic which I'm starting, but we haven't discussed about Jenkins yet. But where does the Jenkins fit here correctly? That is what all you need to understand. Try to understand, team, here is that the Jenkins is a tool basically, or for build automation tool we call it. So before you understand Jenkins again, let's say that I just discussed that this is the build process. I have it, the 5 steps I need to perform it using Maven. I'm going to perform this one. I'll say Maven compile, Maven package, everything I'm going to do. But how frequently should I build the code, right? That is the question again. How frequently we should build the code? That is, if you have it in your mind, team, Earlier days we used to build once in a day, maybe that is what we used to do it, but later we said that building once in a day is having some problems. Let's do couple of times in a day or multiple times in a day. But as per the DevOps standard now, as per the DevOps standard, because we are looking for more speed to deliver the application, as we see that whenever there is a commit happens or whenever there is a push happens to the centralized repository, just like we pushed a centralized repository from the local to the centralized repository, as soon as there is a push happens, as soon as there is a change detected in the centralized repository, we must start this build process automatically. That is what we are looking for, right? Now that is what it is, team. So let's considering that one, let's say that there are 20 times they are getting the updates in a single day. So I have to build the same code for 20 times in a day, right? So 20 times building the same process is a tedious task or a boring process for the build engineer or build release engineer, whoever works on this process. Basically, he might miss some steps or he might do something unusual because of the repeated process. He may feel bored and he may do it. Now in order to avoid such mistakes, again we need kind of a tool here to automate the process, right? Automation is that whenever there is a change, get the source code from the GitHub into the local machine, use the Maven to build the code, perform the steps again, and then we need to tell that, okay, Maven, do this. Once Maven builds successfully, let's say that I want to send a notification also saying that sending an email to the end user, the build is successful. So we have to perform this, right? Copy the code, get the code from the source code, perform the build steps completely, and finally send the notifications also. If you want to do some other actions also, you can do it accordingly. This is all the things we're gonna do it accordingly, right? Now this is where, team, in order to perform this complete steps, end to end process automation, end-to-end process automation, we use something called as Jenkins as a tool which will help us to automate this process. So simply, team, Jenkins, Jenkins is called as a build automation server, or it is also known as a continuous integration server, which helps us to automate this entire process by taking the source code from the, by monitoring the source code tool, get the source code, and then build the steps, and finally generate some alerts or whatever it may be based on the failures, give the results according. That is what all it is going to do it. Simply we call this is as a thing. So Jenkins helps us to build a pipeline which refers to the series of steps executed in order to reach the end code, right? A pipeline, team, we also call it as a pipeline right now. This process, whatever we're doing it so far, again, the 5-step process is also known as a continuous integration process, or it can be referred to as a continuous integration pipeline. I hope everybody might be hearing about something called as CI/CD pipeline. If you break that into two pieces, something called as CI, which is called as continuous integration. When I say continuous integration here, the continuous integration is nothing but the 5 steps which we are doing it. But the way we are doing is continuously we are integrating the source code into a single executable file by taking the source code from the centralized repository, and we are doing the various operations again. Continuously, we are repeating the same process every day multiple times. That is the reason it is called as continuous integration server, which is also known as a continuous integration pipeline, using which we are able to generate an artifact, nothing but a war file or nothing but an executable file. The goal of a continuous integration pipeline, team, is to generate an artifact or nothing but we call it as an executable file to that can be deployed onto a server. Okay, because that is what we do it. And finally we can take that executable file and deploy into a server where that can be running it, and then once we can start using that particular application accordingly. So this is what is the just introduction, team, which I'm talking about it. So let's say that just to quickly recap it, once the source code is available, we do something called as build code process. Build code process is nothing but converting the source code into an executable format. How do I convert into an executable format? There is a build process involved in it. There are 5 steps that we do it, which is called as compilation, code review, unit testing, and then finally the code coverage, and finally the package. Package is something you convert the entire code into an executable format by taking all the dependencies, whatever is necessary completely, we're going to do it. In order to perform these steps, team, we're going to use a tool called as Maven as a build tool. That is what we can do it. But here again, Maven as a build tool which can help us do the process. But in a real time right now, we are thinking about a continuous process completely, or we are thinking to make it much faster. So we are looking for an automation, because as per the DevOps standard, we must repeat the same process, or for every commit that happens to the centralized repository, If I get 20 commits in a day, 20 pushes in a day, then I must build the same process for 20 times. It is a tedious job. So we are looking for an automation here. That is where Jenkins comes into the picture. Jenkins as a continuous integration server or an automation server, which helps us automate the entire process accordingly. Now, this is all about the team, just the introduction about your Maven and introduction about your Jenkins, what exactly we're going to do with this. So what exactly we have to do now here is team, we're going to take a server again, just like whatever the EC2 instance that we are working on so far completely. Here, we need to install the Jenkins, right? In order to install the Jenkins, we need Java because Jenkins is a Java based tool. Means in order to work with Jenkins, in order to install the Jenkins itself, we must install the Java first of all, Java software, and then install the Jenkins server. Then use the Jenkins server to automate the entire process using a Jenkins console. Similarly, as I told again, the entire build process will be carried out by your Maven. So Jenkins not going to do anything here. So we have to integrate Maven with Jenkins so that Jenkins can run the Maven commands or Maven process using Jenkins account. That is what is called as Maven integration with Jenkins or Java integration with Jenkins, or Git also need to be integrated with Jenkins, so that Jenkins is just a dummy tool here, which is just like, collaboration. It is like a collaboration tool. You can think about much thing. So it is going to help us combine all the tools together and build a automation for us. That is what all we are trying to achieve. Now this is what it is, team, as I told. So on the Jenkins machine now, we need to have the Git should be installed. Assume that this is the same server. So far we're working on Git. I'm going to use the same server to install the Jenkins also right now. As to we have Git already available on my machine. Second thing is that we need Java. We're going to install the Java right now, and we're going to install the Jenkins. And we also need to install the Maven on the same server so that we can integrate all these things, tools with the Jenkins accordingly, and we can use the Jenkins to automate the entire CI/CD process. Right, that is what all we're going to do it here. So Maven does the build with all 5 steps. Does Maven keeps doing for all 20 commits, but Jenkins takes that process automated by running Maven commands without human intervention. That's absolutely correct, Santosh. That is what all about the Jenkins and Maven. You're absolutely right. How can I have the git bash session not expire? Okay, that settings will give you at the end, maybe Gautam. We'll do it. Okay, so I'll give you the steps. You can go with them accordingly. I'll just put them into the repository. You can look at later. So, but let's continue here, team. Here it is, right? So here, team, try to understand. So how do I install everything again? So let me show you the installation instruction completely. Let me close this one, team. Have it here. So in the same repository, team, here, the same repository which I have shared with you guys. So here it is. There is a Jenkins folder, right? Jenkins folder is something available here. There is a document I have kept it, how to install Java, Jenkins, Ubuntu, everything. Okay. So here it is. I have installation instruction for Java and installation instruction for Jenkins and installation instruction for Maven. So these instruction you can follow manually, team. You can run one after the other. That's one way of doing it, right? Or in order to just to make up, speed up the process a little, I have a shell script here. Set up Jenkins. In this also, we're going to do the same thing. See this, we are running the same commands here, but I'm going to run with the script. That is what all I'm going to do it. So what I'll do is here, team, is that I'm going to clone this repository into my local machine. If you are interested, follow me. If you are interested in manual steps, follow the manual document to run all the commands one after the other. That is what you're going to do. Let's say that git clone, I'm doing it. You know how to clone the repository now because I shared with you all already. Just do the git clone. So it is going to copy entire this labs into your local machine. Do ls-l. So I have the du labs here. So go to the du labs in simple words. Okay. So here it is. I have all the folders. So let's go to the Jenkins folder here, right? And here, team, I have the script available. So this script can be run it, or you can follow the manual instructions. Just to save some time here, team, I'm going to run the script. You can see that it is going to happen. I'm going to show you everything, how exactly it is going to do it. First of all, team, in order to run the script, we need to give the execute permission. So let me change the permissions for it. 755 for setup Jenkins. Now, in order to run a shell script, team, just to execute this one. In order to execute a script in my Linux, what I'll do is I'll just say / and run this script. So it is going to install the Java, it is going to install the Jenkins, it is going to install the Maven and give it ready for me within a couple of minutes. Let's run this one. You can see that it is trying to install everything automatically. Just trying to save some time. We can concentrate more on the pipeline accordingly. That is what I'm trying to do it. So just enter it when it asks you to enter it here. Just continue with the rest of the things. So this is installing all of the things team. So it is just, taking it everything automatically rather than you run the instruction manually. We're just doing it automatically. That's all I'm doing it. So once this is done team, I'm going to show you all the things where exactly they installed on all those stuff. So you can follow the same thing also. By default, it will be the default settings which you are following it. Okay, just like when you install some installation on your Windows machine, it always goes to the C drive program file, something like that. So whenever we install the tools here also, they will have their own installation locations. So we will show you, or I'll show you all those installation instructions, and then we can make a note of them so that we can configure them with the Jenkins server accordingly. Again, all the things we're going to see that. I hope it is almost done team. Couple of seconds more, we should be good. Okay, so we are done team. So let it go with it. So let me show you where exactly it is installed, all the stuff. Just to show you the things team, I'm just doing it. Let's say that Java hyphen version. So I should be able to get the Java version here. This is the Java command. Basically, you can see Java is responding to where exactly Java is installed is user, right? We call it as JVM, user lib JVM. These parts, everything I mentioned in the documentation also team, you can go with them, but this is what it is. Java 8, this is where the Java is installed team. This is your Java installation location, which we call it as installation path, or Java home you can call it. So let me take a path this one team. I consider this as my Java home. Just to show you that, let's say that this is my Java underscore home value. So we have to configure these things with Jenkins. So I'm just making a note of these things. This is my Java location. Now, similarly, let's look for the Maven location also. Let's say that Maven installs in this one as per the script, or whenever we do manual instruction also. So this is where the Maven is team. Apache Maven here. You can see that. Let's say that Apache Maven is here. Just to see that it is working or not, go to the bin folder. Let's say that mvn, right? mvn hyphen version, right? See that the Maven we installed is successfully responding here. So this is the Maven path, I'll call it, right? Which is nothing but your opt this one. So let me make a note of this one also here. Let's say that this is called as Maven underscore home, right? Is equals to, this is the path. So similar team, we have now know the Maven path and Java path also. Similarly, let's know the Jenkins path also, where exactly Jenkins get installed. So here it is team, the default path or installation location of Jenkins is cd var lib Jenkins. This is where the Jenkins resides, or everything related to Jenkins is available here. There is no Jenkins version command team, but this is can be considered as your Jenkins home. So whatever you do consider Jenkins right now, all the Jenkins information will be available inside this particular folder in your system accordingly. So consider this as your Jenkins home, right? Jenkins underscore home is equals to, this is the path actually. These are the default locations team when you install this one. So we must be aware of these paths. So if I want to troubleshoot some issues, or if I want to look at some information about these tools, I should be looking at these directories so that I'll be able to find out some information about these things accordingly. Now with this understanding team, let's try to access my Jenkins, because Jenkins is a web-based tool. So we just have to work on the UI itself. Jenkins runs team. Jenkins runs as a process basically. Let me show you that. ps-ef grep Jenkins is a command to show the Jenkins process on your system. Now you can see that Jenkins is running by default. Jenkins, whatever the process it is running it. and Jenkins is available by default on a port number called as 8080. So in order to access this 8080 team or Jenkins, in order to access an application, Jenkins is also a software team here. Jenkins is also an application here. If I want to access this application now, how do I do is that I need to take the server IP address, nothing but the public IP of your server. So let me log into my AWS console once, console.aws amazon.aws.com. So let me log into this and we can get the public IP of your Jenkins instance or wherever the server that we are using it right now. So let me log into my account team. This is what I'm doing it. So here it is. I can go to EC2 right now and we'll see that there must be a server, right? Whatever we created yesterday. So running instances. This is the server team. I have it. Let's mark it this as Jenkins, whatever it may be here. Let's say that this is what it is, right? Now team, in order to get our access to this machine, we get the public IP address just like you took to connect to that SSH. Similar to that one, we are also going to do this one accordingly right now. Let's take this one, go to the browser, enter the browser IP address and colon 8080 you need to give it. When you hit this one team, you will be able to see that accordingly the Jenkins home page or a login page. This is the default page that comes up. Basically you just need to understand. So whenever you install Jenkins fresh team, it is going to unlock the Jenkins. Now it is asking you to unlock it. It is asking you the default administrator password. Where exactly this is that you need to go to the Jenkins home team. You can see that there is a path which is giving here and there is something called as initial admin password. Just copy this one completely and go to the server where you have the Jenkins running. Let's say that cat and the path that you configured there, just do that one. You will get a string here. This is nothing but your password to log into the Jenkins for the first time. After that, we're going to configure our own username and password. But the first time login, you must do this one. Copy this one, right? And go back to the console here and enter the password here, right? And say continue at the bottom. So it is going to get you inside the Jenkins right now. Don't save it. Now here team, it is going to ask you to customize the Jenkins. First of all, because we are very new to the things, let's go with the install suggested plugins. Now this is where we're going to click on this, right? And once this is going to install a set of things which is necessary to run the Jenkins seamlessly for our CI pipeline process, everything. So we're going to work on this accordingly. Let's get it started. Once this is started, we're going to start working on our pipeline accordingly. Okay. So we will integrate Maven, Jenkins, everything. And meanwhile, team, let me provide the Java repository, which I'm going to use it. This is a realistic Java application where we see all the Java code available here. Most of the source code is available here, team. I'm going to share this repository with you guys. So you can also use this one for all the related activities, whatever you want to do it. The way what I'm doing it, you can do it. You can see that, team, there is a lot of Java files available here. Java code, everything is available. So we're going to use this Java repository for completing our CI pipeline or understand how do we going to build the code and everything. So let me share this repository with you all. Please make a note of this one, or we'll ping that in a WhatsApp group also. Please make a note of this repository to practice it while you're doing it, while you are implementing it. This is what I'm going to do it. But here I'm coming back. So here it is, team. It is asking you to create your admin user first of all. Let me create it. Enter admin and admin team. So don't come back to us and say that we forgot our username and passwords, right? So just to make it very simple, keep it admin for practicing until you understand some Jenkins part. So just keep it as admin and admin, which will be helping us accordingly. Save and continue. So once this is done, instance configuration, you can leave it as it is and save and finish this one up. Now it says that Jenkins is ready successfully. Now let's say start using the Jenkins. Now this is how, team, I set up my Jenkins right now. This is what all we're doing it. We have successfully set up our Jenkins. This is the default console of your Jenkins, where you see left side there are many options available, and similarly you can log out and log in on the right hand side corner top. All these things can be done, but let's try to understand, team. As I said, like Jenkins is just a dummy tool here, which is just going to which is just going to basically whatever you instruct it, it will going to do. It means that if I ask you to do work with Maven to compile something, it is going to compile the source code accordingly, right? It is going to build the things accordingly, right? Now in Jenkins terminology team, we say that we're going to create a project, or we're going to say that we're going to create a job where you need to write a set of instruction, like automating stuff, right? Automating is nothing but multiple instruction, putting it together and executing them as it together. That is what is called as automation, right? So here team, if I want to do the things, here, right, simply if I want to ask, or if I want to say Jenkins to do some task, we say that we're going to create a Jenkins job. That is what all you need to say it. Now, in order to ask, or in order to create a job in my Jenkins, we always use something called as new item. Okay, just say that you're creating a new item here. Whenever I say it is going to ask you the name of the job that you're going to say that. Let's say that this is my uh, first job, something I'll give it, whatever the name you want to give it, give it. Now here I'm going to see that a freestyle project simply, and then say okay, right? This is what all you're going to do it. Now when you say this one team, it is going to present a UI where you can put some instructions, whatever you want to do it. And this is the page where it is showing you basically there are various options will be available accordingly, right? If Jenkins has to get a source code team by talking to the GitHub or some kind of centralized repository, I can use the source code management. Let's say that I'm going to choose the Git because we are using the GitHub itself as a source code management tool. Select this one. It is going to ask you the repository URL. So whatever I have given you just before, let's say that this is the URL. I'm taking it, right, and I'm giving it to the Jenkins. You just need to give it to the Jenkins team. That's all you're going to do it. If it is a private repository, it might ask you the credentials. We can put the credentials here. Since this is a public repository, we don't need the credentials. Just leave it as it is. Just enter this one, ensure that there is no error, it is showing up. Once this is done, let's come below, right? There's build triggers. We're going to understand them in a minute. Just hold on for some time. And build environment, there's various sections. Now build section is very important for us team, where you ask Jenkins to do something on your own again. Let's say that when I say get repository, it is going to clone it. Jenkins is going to clone the repository into my local system. And here I can instruct use Maven to build the code or something like that. Or let's say that I can run a shell command also. Let's say that a simple shell command, I would like to run it for now. This is first job, just a dummy job, which I'm going to do it. Here, what I'm doing is team basically, let's say that I want to create a file. Let's say that touch hello devops.txt. This is the file I'm trying to create it. Means this is just a file team. I'm creating it on my system. That is what all I'm going to do it. So let's save this one. In this job team, there are two instructions I gave it to my Jenkins, which is that clone this repository. That's what I'm giving it. I asked to clone this repository. Second thing is that create this file. That is what the task I have given. There are two tasks given to my Jenkins, and then consider this is my automation here right now. Let's say that I'm going to save it. Save the job. Now you have just given a script team, or you have prepared a script itself, but you need to run the script to make this happen, right? So in order to do that one team here, we call that as build now. Building is something running the job. When you run the job, it is going to execute the instruction that you give it to the Jenkins job accordingly. Let's say that build now here. So when I say build now, it's going to start creating the things accordingly. Okay. So here it is. You can see that it is doing something, building the workspace folder. It says something called as varlib Jenkins. Under the home folder, Jenkins home, it is creating something called as first workspace folder. Under that, it is doing something called as first job, where it is actually cloning the repository. You can see that it is cloning the remote git repository, and it is cloning it whatever the way it wants to do it. Finally, it is also creating the file, right? So just to show you this team as it is, like it is going to get the everything from the GitHub repository and putting it onto Jenkins machine. Where it is putting it, that place is called as workspace. Workspace is a folder. So this is the path where it is actually cloning the repository. That place is called as workspace. So just simply look at this one. Here it is. I'm just going to cd this folder team. This is called as a workspace folder. If you see this one right now, you will see entire things, whatever is there in my GitHub repository, it is completely cloned out here, right? Along with that, it also created a file called as hello devops.txt, which means that whenever you try to do something from the Jenkins job from the UI, it is always going to run something from the workspace folder. You need to understand it, okay? So here we cloned it, and here we're gonna understand, or here from where itself Jenkins going to run all the commands. Jenkins uses workspace folder to run all the commands accordingly. If I given a touch command also, touch command was executed here inside that workspace folder. The file was created under the workspace folder only. With this, you can understand that Jenkins runs every command inside the workspace folder always by created at the runtime when you create it accordingly. This is what you do, team. Now with these steps, we are able to clone the repository, or Jenkins was able to clone the repository, and it is also able to do whatever you do it, right? Now what I can do here, team, is that first step I told you, like, okay, clone this one. Now I can integrate Maven with Jenkins, and I can ask run the Maven commands also, right? That is what all we're going to do right now. So let's go ahead and then do that. First thing is that, team, we need to configure the Jenkins before we work with Maven stuff here. Since Jenkins is installed right now, but Jenkins does not know where exactly Maven is in my system, so I need to configure the Jenkins with the Jenkins path, or Maven path accordingly. Now that is where, team, we talk about configuration of Jenkins. How do I configure the Jenkins? If you are thinking about configuring the Jenkins, we're going to go with this manage Jenkins page. Go to the manage Jenkins simply, and there are various options will be available here. Look at that, manage Jenkins system configuration. We are configuring the system right now, or to make some changes accordingly. Here there are various things available, team. There is something called as global tool configuration. Since Maven is a tool, or Java is a tool that sits on your system, we must configure them on your global tool configurations. Click on this one. So it is going to show you various options. First of all, it is asking you to configure JDK. So let's say that add JDK here. JDK is nothing but your Java. You don't need to install, team, because we already installed Java on my machine. Just deselect this install automatically option. So it is going to ask the Java path, right? Let's say that this is Java 1.8. I'm doing it. And the path here it is. We noted down at the first Java home. This is the path of my Java where I installed on my machine. So I'm going to put it here. By default, Git is detected, so I don't need to configure the Git one more time. That's good. Now if you come a little bit below, there is Gradle, there is Ant, there is also Maven. So we can add the Maven here simply, and we don't need to install again separately. So deselect this one. Select this one is, let's say that this is Maven 3.6. That is what all about it, and put the Maven home path here that we noted down already at the first. Keep this path where we installed it into the Jenkins, right? So we are integrating Jenkins with Java, Maven, Git, and everything here. Maven integrated here, and Git is integrated here. This is default detected by the Jenkins automatically, and this is the Java path which I'm giving it a call. See that these are the things, team, which we have it to configure the things accordingly. Now we have integrated our Java, Jenkins, Maven, everything with the Jenkins. Now we will be able to run our things accordingly. So here, team, as per the steps again, so we are going to implement the CI pipeline right now. The steps are this one. So I'm going to create a job for each of this one. Compilation is a separate job. For code review will be a separate job. And then unit test is a separate job. Packaging is also a separate job. We're going to create 5 different jobs right now. And we consider that as a CI pipeline accordingly. How we're going to achieve that one, all things. We're going to look at it. But this is what all you need to check it here. Let's check it accordingly, right? So let's go ahead and create the pipeline, team. Here I'm going to create the job here, which is going to be a compile one. Let's say that I'm asking my Jenkins to compile it by using the Maven everything. Let's say that job one compile, I'm giving it. I'm name of the compilation job. So say okay here. Simply use the source code management, because we need the source code to be cloned first of all to compile the things. So I'm going to use this repository here. Simply keep this one and give it here. This is the source code, team. As I told, we're going to use it for entire building process. So here it is. We are simply using it. Build it triggers, team. Let's consider that when this job going to trigger it means, as I told, like this is the first job that we are building it. So this job should be dependent on your source code management tool, means that whenever there is a change happens in the source code management tool like GitHub, whenever somebody pushes something to the repository, that's when this job should trigger automatically without any manual intervention. That is what is something we are looking to automate. In order to do that one, team, there are multiple options here, in which we're going to use something called as poll SCM is option. So poll SCM is option, team, which I'm telling my Jenkins to check the Git repository frequently or based on a schedule basis, and then we are actually going to run that accordingly, right? So here team, I'm going to use a schedule called as, if you want to understand this one team, you can look at something called as a website called as crontab group. This is where you can understand it, most of the things, right? So let me show you that. What happens if I put first 5 stars team? Look at this. This is a syntax I'm using it here, which means that I'm going to use 5 stars, right? Just to show you that I'm using 5 stars. If I say 5 stars, mean that at every minute, means that every 1 minute this is going to run, that means that every 1 minute my Jenkins going to check the source code, and if there are any changes, it is actually going to get the things accordingly. So that is the reason I'm using this syntax team. If you want to understand more about this crontab, look at this documentation. It will help you understand completely how exactly this works on all things. But 5 stars means that here we're gonna run this job, or we're gonna look at our Git repository for every 1 minute, and where we will be able to fetch the changes if there are available, and it is going to run it automatically. Let me show you that anyway. Here, let me go back to this console here. I'm just using the 5 strings. It is saying, do you really mean every 1 minute? Yes, of course we mean that one. Let's keep that configuration as it is. Now here team, in the build step, this is where we are going to ask Maven now. There is an option called as invoke top level Maven targets. Here it is going to show you the option called as Maven team. Choose the Maven that you configured it. And there is something called as Maven goals. Maven goals is something we're going to ask Maven to do what. That is what is a goal, we call it, simple words. Now I have mentioned all these goals in this document team. You can follow the document also once. There is a setup CI basically. I showed all the configuration paths here, configure everything. Now here team, we are talking about the job one, and I have given you the Maven goal very clearly. The Maven goal is called as compile. Means that we are asking Maven to compile the source code. That is what all we are trying to do it. Okay. So here it is. I'm just going to give this goal to this one. So Maven going to compile the source code, which means that converting the high level language into a low level language. That is what all it is going to do it. So simply save the job and build it. So it is going to run the job, and we'll see how it is going to do it. The automatic things will gonna happen also, but I'll show you. We need to make the change in the source code so that it is gonna happen automatically. But that thing will do it at the end maybe. But look at this. It is actually doing something here. You can see clearly that Maven is running a lot of stuff. You don't need to understand all these things, team. This is a headache of developer anyway. We just need to ensure that as a DevOps engineer, ensure that this job is going to be successful. If it is failing it, simply get back to the developer saying that look at these errors and then fix the code accordingly. So don't worry about all these things, what is happening or what Maven is doing. You just need to understand that whether it is building the workspace, yes, it is going to this particular folder. It is cloning the repository completely, and it is running a command called as Maven compile. You can see that it is running the Maven compile command. When you run this one, basically it is actually using a lot of things, whatever it has to do it. It is doing it. Finally, it is going to give you the output team. Whether I am going to show you the bytecode files also, which is going to generated by this one. Here it is. Go to the end. Right here it is team, just to show you that it is compiling the 13 source files and it is putting into this particular path, right? So let me go to this path and I'll show you the files basically, whether they are compiled successfully or converted into bytecode or not. Go back to the server. So let's go here, cd space that particular folder where it was telling it. Look at this folder now. Okay, there is more directories available. So here it is team, go to the utilities folder. Here basically you will see that various class files, right? You can see that these are the class files. This is nothing but the bytecode team. If I open this file also, you will not be able to understand anything. So this is how it is going to show you the contents. We cannot understand the stuff so easily. This will be understanding by your, the things accordingly. Means the system going to understand this stuff. That is why it is called as bytecode completely, and then Java will take care of it accordingly. Now this is about the things team. This is about the compilation process basically that you just need to understand accordingly. Now this is the first step team in your CI process basically. Try to understand. Once this process is completed or once the compilation is completed, the second step is code review. Now, in order to do the code review team, there are some dependencies that we need to run it. So let me talk to you about that one, right? So as I told team here is that Maven is the one who is going to do the code review, right? That is what I told you, simple words, right? Let's say that Maven is going to do the code review, but how Maven is going to do the code review team? Let's say that there is an example I'm going to take you here. Let's say that you have purchased iPhone. Basically iPhone comes with the default applications what you have it, right? That is a default. But if you want to utilize more application team, you go to App Store and you install whatever you do it. That is kind of extending the functionality of your phone according to your requirement, right? That is something we call it. Similarly team, Maven comes with the default settings. Something like compilation is the default goal of Maven. But in order to, for your Maven to do something called as code review, by default Maven cannot do it, but we can extend the Maven functionality with a thing called as plugin. Think that team plugin is kind of an application that you're installing from the App Store to do some task, right? So similar to that one, Maven uses some plugins to perform the next step basically, which is nothing but in order to do the code review, right? Code review is the next step basically. In order to code review, Maven uses a plugin called as PMD. That is what it is going to use it. Similarly, in order to do something called as unit testing, that is the next step we're going to perform it, unit test. Here also it is going to use a plugin called as JUnit is a plugin, kind of a next application. We're going to integrate with Maven accordingly. Similarly, it is going to use something called as code coverage, right? Code coverage was the next step again. For this, it is going to use a plugin called as Cobertura. So these are the various plugins team that you must need to have an idea. If you are doing something, you will also get to know automatically. If you are feeling for the first time, that's okay. Consider these are the like a plugin, nothing but extending the functionality of a software, which we need to use it to this one. These are all defined, will be the Maven team. We're going to define it. Now, what exactly we going to do on the Jenkins, right? Jenkins also some kind of plugins team. Jenkins also has something called as plugins. Those plugins are used again to perform some operations. To extend the functionality of Jenkins also, we're going to use the plugins accordingly, right? Now here team, these plugins are integrated with Maven already. We don't need to worry about it. But here, let's say that when I use a code review, it is going to generate something called as XML file. Means whenever you do a review, there will be an output, right? The output will be in the format of your XMLs basically. Every output here for every result that is going to come up in the XML format. But as a human being, we cannot read that XML format outputs. That is the reason we're going to use the same steps here, right? We're going to ask everything to it, but this is what it is. Jenkins has its own plugins basically for code review. It will be done by Maven only by default. But what exactly the plugin of your this one going to do is here, when you do code review, there is a plugin called as PMD for Jenkins. Again, the same plugin name team. Plugin name is same thing, but the functionality or the purpose is different. Maven PMD plugin going to generate the results in the actually does the code review there. It is going to generate the results in the XML format. And Jenkins PMD plugin team, it just takes the XML file and converts into the HTML format, so you can easily understand thing accordingly. Similarly, Jenkins has the JUnit plugin accordingly. This is also will be there, and then this is also will be there, right? This is also will be there. All these plugins are there for the Jenkins also. Only thing is that these plugins are just converting the XMLs into the HTML format for the readability. That's all it is going to do it. Otherwise, actual task will be taken care by the Maven accordingly. That is what all we're going to do it. We can use that also, Permality, definitely again. So we will do that also, but not in this course. Okay, this is just a basic level, so we are covering the basic things here. So here it is team, that is what we are doing it. So I'm going to use the PMD here. Right now we need to install the plugins in the Jenkins accordingly. So let me show you how to install the plugins in the Jenkins first of all, and then we can go and configure the rest of the steps for the rest of the task accordingly. That is what I'm going to do. So let me show you here. So here it is Jenkins. In order to configure anything with the Jenkins team, we always go to the manage Jenkins page again. Go to the manage Jenkins and go to the manage plugins this time. Click on the manage plugins. So here team, there are various sections, updates, available, and then there is something called as installed also. Available is the section team where you can find various plugins accordingly. You just have to check them. Let's say that I'm going to search for something called as PMD. You can see that there is PMD is visible here. Just select this one and you can simply click on without install without restart. So it is going to install whatever is necessary for PMD to run it. So we are just installing the plugin called as PMD accordingly. Similarly, team, we're going to install the plugins of your Jenkins in the Jenkins console. But whereas Maven plugins are maintained in the source code directly, there is some file called as pom.xml here, in which we're going to maintain this file is for your pom. Because Maven does not have a UI team. Maven maintains everything in a source code format. So Maven plugins are mentioned in this one. If you look at this file, there is something called as PMD. So there is a PMD plugin mentioned in the Maven source code. Similarly, there is something called as, right, JUnit. You see it, JUnit will also be there. So JUnit plugin is also there for testing purpose. Similarly, you must have the Cobertura also. This is a Cobertura plugin that you can see it available. So all the Maven related plugins are mentioned in the source code directly. This is the file will be written by the developer again. You need not to worry about it. On the Jenkins part, you can run the things according to your requirement, whatever you wish it. Okay. So PMD is installed here, team. Okay, so let me get back to this one. We need to install a couple of more plugins here. Go to the available again. So I think Cobertura or something, I'm going to do it. So there is a Cobertura plugin. Let's install this also. And the JUnit might be installed team already, because while we setting up Jenkins, we said that install suggested plugins, right? Install suggested plugins would have the JUnit also, but let me validate it whether it is installed or not. Go to the installed section once and check whatever you have it. Let's say that JUnit. Okay, there is a JUnit plugin already installed it. Similarly, Cobertura, we just installed it, and PMD we installed it just before, so that is available here. Now along with this team, we're going to install one more plugin which is helping for our CI pipeline. That is going to be your what is that plugin? Basically build a pipeline plugin, we call it. So let's go to the available section. We're going to install another plugin team which is going to be build a pipeline, we call it. So there's a build pipeline plugin, we have it. Just select this one and let's install it without restart. So that's all we're going to install, team. These are the plugins we required for our CI implementation. So we're going to simply look at it accordingly. We'll do it accordingly. Okay. So these are all the plugins, team. Whatever is necessary now we installed successfully on the Jenkins side. Whatever is necessary for the Maven, which is already part of your source code repository. So you can use that accordingly. You don't need to worry about the things. Now here, team, I'm going to create the second job and we're going to link them accordingly. Let's create not manage Jenkins, create a new item here. Let's say that job 2, I'm going to do it, which is going to be code review, right? And they say that freestyle project, say okay. Only thing, team, we're going to configure the same thing again here, source code management, take the repository. Let me get back here. So I'm just taking this one and giving the repository here. Now, when this job should run, team, build triggers. You tell me that when this job should be triggering it, because this is a sequential steps, right? Once the compilation is over, this must be triggered. Yes or no? That's how it will be, right? So that is the reason, team. Right. All the things are available in this one already here. You can see the plugins I said here, whatever is necessary. All the steps are here. And here also I mentioned it completely. You can follow this document, but I'm just showing you this one right now, which I'll be implementing the same thing. Okay. Okay. Because freestyle allows you to configure whatever you need it functionality. That is what we do it actually. Right now we are at the beginning stage, so we would like to do our own steps. That's the reason we are using freestyle. We are configuring our own steps accordingly. Then later once you can look for the advanced step, whatever you need it according to requirement. Okay. So here it is, team. Try to understand now. This job should be triggering it after the compilation job is over. There is a dependency now, right? This is a job 2. Compilation should be successful, then this job should be triggering it. Means that once after the compilation is completed, this job should be automatically triggering it. That is the reason I choose some option called as build after other projects are built. Select this one and give the dependency of your job 1, right? Let's say that job 1 I'm giving it, which means that Once after my job one is completed, I'm asking to run this job. Means this job is going to watch my job one for the completion. Whenever that completes, this is also going to trigger it automatically. So this is the dependency that we are building it. This is nothing but we call it as creating a pipeline. So I'm going to show you the entire flow also one more time. Let's consider this one, second one. Now here the build step again, we are asking Maven to do something here again. Choose the Maven, and there is a goal for the Maven to configure the things. Right here, I'm going to choose it. So Maven goal is this one, team. Whenever you choose the goal, PMD is the one which you're using it right now. So PMD related goal will be available. Take this goal and give it. Now, as I told team, this is a code review analysis. Basically, it is going to generate some results, and it is going to be generating an XML, and we want to convert that XML into an HTML format. So assume that with this step, it is going to generate the XML files. Now I need to convert that XML files into the HTML format. So what I'll do is I build it, and then I do a post build action. Once after this one is completed, do a post build action and do the publish PMD analysis results. PMD is the one which is analyzing the results, right? And it is going to publish now. Jenkins is going to publish that PMD analysis results, whatever the results coming out. Now that is where we need to give some input to this one, team. It as like it is going to generate some XML file. This is the post build action that you just need to put it. So it is going to show us the results accordingly. We can go this one, save it, and simply build now this one. We will see the results automatically after this job is run successfully. I'll show you the results, what kind of errors you would find it, and what exactly those means. And since we not to proceed or not to proceed, we will check it accordingly. So here it is, team. Once this job is getting successful, you can look at the log also as it is doing it. Now it is successful already. If you want to look at this log, look at the log, team. There is something, the big log will be available, but it's not the important point here. You can see that there is something called as on the left side, there is something called as PMD warnings, right? PMD warnings is something where your results are available, publishing the PMD analysis results here. Look at this here, click on the warning side, whatever the warnings it has it, right? Here, team, look at this. This is what it is showing you, total 11 warnings. Click on this something here, whatever it is, address book. Let's say that this is what it is, I'm doing it. So here it is, team. I think there's some issue with the Jenkins user, but let's click on this one. So there are some warnings here. You can see that below it is showing you property.java. What kind of error it is, team? We need to check that. See here, there's an error. Basically, is something called as empty finally block or empty code. It says basically you should not leave any empty codes in the source code. Actually, that leads to some extra utilization of resources and everything accordingly. So it is telling you that error basically here. It's a warning. It is not really an error, but it's just a warning basically. Leaving the empty code or empty blocks will lead some extra usage of your resources on the system because of the application consumption, everything that may lead to your leading problems. That is why I say it. You can see that there is a block here. He wrote a finally block, but he did not write any code. The developer did not write any code. This is purposefully made, team, just to show you the results. That's how it looks like. So this is what it is. This is how it is then taken care. So this need to be filled out. We can send ask developer here to fill this one out why you are leaving empty. This may cause some issues accordingly in the productions. That is the reason we want to build it accordingly. This is what all we're doing, team. Let's say that this is the issues that you have it with your things. Now this is the code review process. Basically we do it. Now after this one, we do a code unit testing also. Let's go and build the unit testing, and let's say that I'm saying job 3 unit testing, right? Unit test, I'm doing it. I'm saying the freestyle project again, so it will allow me to do whatever I want it. Source code management, select the git repository and choose your repository on which you want to perform the unit test cases. Here it is, get the things done. And this job again, team, should be completed after the code review. So I'm going to build after the projects are built. Let's say that job 2 is what the dependency I'm giving it. So it is going to trigger automatically after the code review is completed. Finally, here it is, and using something called as invoke top level Maven targets, and here choose the Maven that you configured, and goal, team, again you can copy it from here. The goal is simply test. I'm going to take this one out, sorry, and keep it here. Test is the goal, and again unit test going to generate some results in the form of XML, so we need to convert them also. Add a post build action here. which is nothing but the JUnit is a plugin to do this one. So we use something called as JUnit test results publish. This is what I'm doing it, and you need to pass on the XML values here, whatever they are, that is available under this section again. Take this value, whatever it may be. If you work with these things, team, you will understand it. For now, just follow me to understand the things full flow. Just save this one out and we run it. Build now. This is going to show me the test results, how many test cases are passed, how many test cases are failed. If there are any failures, we need to take the results accordingly. All these things will be covered by your things accordingly. That's all we're gonna do it. So it is successful, team. Just click on this one. On the left hand side, you see something called as test results. So let's click on the test results here. It is showing you some test result, team. It says that 0 failures, which means that all the test cases are successful anyway. Look at this, whatever the test cases which is ran by this one, all these test cases are passed, whatever it may be, right? All these test cases are passed successfully. So you can see that, team, multiple test cases were executed, everything is successful. But how many test cases are being executed here? That developer covered all the unit test cases, or he created or he covered only the part of the code accordingly, right? Means let's assume that my source code having 100 methods, team. Now he may cover only 20 or 30. We don't know that results. In order to know that things, basically we're gonna actually do the next job, which is going to be a code coverage. Simple words. Let's say that I'm doing job 4 code coverage. This is what I'm doing it. Simply freestyle project and say okay. Correct. So this is what I'm doing, team. Again, I'm selecting the source code here. Whatever it is, just select the source code. Build after the processor build. This should be done after the unit testing is being done. So let's say that build this one, job 3 unit test taken care. So here it is. And finally invoke the top level Maven targets. Use the Maven and the Maven goal accordingly. This is a code coverage, team. So we're gonna have this code coverage goal, Cobertura goal, basically, because Cobertura is a plugin here for covering the code coverage, everything. So here it is. Just go with this, and this also going to generate the XML file again. So we need to publish the results. Under the post build action, there will be something called as publish Cobertura coverage report, whatever the coverage, and you must give this results accordingly. So use the post build action here, whatever I have given to you guys. Just follow this one and you will be able to do it accordingly. Okay, this one, and finally save it. So you're gonna run this one also now, team. Let's see this one, what general one results it is going to show up, how exactly which will be done, all things taken care accordingly. And this is how, team, we build normally the entire pipeline completely, and then once after that one is done, this will be triggering for every commit that happens on the source code. That is what all we need to watch it. Let's say that here I'll open this one. Here it is, team. There is a coverage report that you have it. Click on the coverage report. As you can see now that, let's say that, as I said, like developer does not do a very good unit testing here. Let's say that he covered only the 25% of the packages, files, classes, 29%, methods, 22%, lines, 21% account, right? So he's not completely doing the testing, team. We need to ask the developer to do more testing so that we will be ensuring that application will be stable in the production accordingly. That is what all we're gonna do it. So this is showing you some results here like this. You need to understand them. If you're not understanding also, that's fine. Just ask the developer to ensure that you get all the full green color here. That is what all you're going to do it. Okay. Now this is about your code coverage, team. One final thing we're going to do is our final goal to generate the package, nothing but the var file, something like that. So job file package, we call it simply CKAG package, and freestyle means that assuming that all the steps are fantastic, now we are completely good with the steps that we did it. My source code is absolutely fine. Now this source code or this application can be delivered into the production or delivered for the deployment for the QA and next production accordingly. That is what we are creating a var file right now, which is the package step completely. Use this one source code and take the project and give it accordingly again, whatever it is here. Once this is done, this should be triggering after the job 4 again, code coverage. Once after the code coverage is completed, run this one accordingly. And finally, we're going to do this things. Build a step, go to the invoke top level Maven targets, use the default goal, and goal is package this time. I'm going to copy paste the goal here. Done. And then there is no post build action team. We are just building the application. That's it. Let's gonna run it here. Okay. So this is what all we're gonna do it. Let's say that build now completely. So it is actually going to show a war file team. War file is nothing but an executable file, like consider that is a .exe file that can be deployed onto a next environment or a server like web server. That is what the goal we are trying to achieve it. Look at this team. It is telling you something called as building the war file or building the executable file. You can think about it. And the war file is available under this particular location. So let's go with this folder on the server and I'll show you the things. So here it is team, very carefully watch it. So here it is, we have a something called as a war file. This is what is nothing but we are actually going to deploy it onto a next environment, or let's say that QA or production. My application is bundled into an executable format. This can be deployed onto the next environment. That we will see it how to deploy it later, but this is what the goal of a continuous integration pipeline actually. So let's consider this one is done. So let me show you the final step here, team. Just to visualize the pipeline flow completely. Let's say that now you have this order team. That's very fantastic, but I need to understand the dependencies on which job is dependent on which job. There is some a graphical view that will be there for you, which will be easy to understand more than this job sequencing. In real time, you may not name it as job 1, job 2, job 3, job 4 like that. Just to understand the dependencies, which job is dependent on which job. There is a beautiful plugin in Jenkins, which is called as build pipeline plugin that we already installed it. Now, how do I utilize that plugin is something we're going to do it. Okay. So here team, in order to do that one, we can click on the my view here on the left hand side. This is the option I'm showing you right now. Under this one, now it is going to ask you to create a new view. Click on the new view option. Now let's say that here my CI pipeline, whatever you call it, and say that build pipeline view I want it. Say okay for it. Now in this one, it is going to ask you team pipeline flow. What is the pipeline flow that you have attached it? Show me the first job. That is what it says that. Select the initial job that you do it, which is nothing but your job one, compile, upstream, downstream, and just save this one. That's all you're gonna do it. Here it is, right? So this is how team, you can see it, a very nice pipeline view here. This is what the dependencies that you see it actually. Okay, this is the one thing you can understand it. Now here team, we did everything, but the only thing that you need to observe is that whenever there is a commit happens on my source code, this pipeline should trigger automatically. Now that is the final step here team. Let's go ahead and make a change in the source code. As per the thing team, every 1 minute that is watching my source code, actually if there is a commit happens here, the pipeline should trigger automatically. I'm not going to touch this one. Let's see that it is going to trigger or not. Let me make a change here team in my source code. Simply let's say that click on it here. I'm just going to do some change here, and then I'm going to commit the change. Means just a commit is required, that's it. So once I committed team here, coming back here, just watch this one whether it is going to trigger or not. I'm just refreshing the page. So if it is triggering automatically, which means that whenever there is a change now happens from the source code side, it is actually going to trigger this complete pipeline flow accordingly. It need to wait for 1 minute team. That is a default interval that we have given. So let's wait for a minute and we'll see if it is going to trigger it automatically. Then we can work on it accordingly. Okay. Okay, still it is not. Okay. I'm just refreshing team. Now you can see that it is working in the flow, right? So this is how team means I did not do anything here basically, but the pipeline was triggered automatically whenever there was a change happened. There was a commit happened newly on the source code management tool. It is quick team because it is processing a little bit faster here. That's all about it. So you can see that it is actually building the pipeline one after the other, the sequence is going down team. Now this is why we call it as a pipeline, right? We attach multiple pipes. There will be the starting point, there will be an end point. So the end point or end goal of a CI pipeline is that we always generate an executable file that can be deployed onto a target machines accordingly. Wherever you want to install that particular application, we can use this executable file and deploy it onto the next environments. That is what all we're going to do it. Now simply team, this is the what call it as a CI pipeline flow, completely continuous integration pipeline. From now onwards team, if there is a change happened in my source code, this is going to trigger this entire flow automatically. It is going to generate my artifact, nothing but your war file accordingly. So this is the entire continuous integration pipeline flow team. Right now you see that without any manual intervention, now the jobs were executed successfully, and it is going to keep on generate the results and generating the results. And you can send, can configure email configuration also with the Jenkins team. That will be there as well. So you can simply send the notifications to developers saying that all the build is successful, or if it is a failure, whatever the results you want to send it out to whomever you want to do it, you can simply configure the things and deliver it accordingly. So this is called as Jenkins related team, how to configure Jenkins, how to install, how to configure, how to work with Jenkins, and how do I create my CI pipeline in this one using the Java project or whatever it may be. The basic steps that we did it completely here. So with this understanding, just go through the things and let me know if you have any questions. I'll stop here. This is all about what we want to discuss with Jenkins also, and Git and Jenkins and Maven is covered for now. So if you have any questions related to anything, please do let me know, then we can discuss accordingly. Shall we get one example from the pipeline type project? Please don't say that. I mean, okay, so we will do that. We'll give you at the end, Pamleti, so don't worry. So I'll give you a documents with which you can follow and complete pipeline project. I'll give you the documents, you can simply follow that accordingly. Okay. I mean, for that, you need to understand a couple of more tools such as Docker and Ansible. So you can follow them accordingly once we understand the tools accordingly. So I'll definitely give you a project. Okay. Right. So any other questions, team? You have it now is open for your questions. Please do let me know your questions so we can discuss them accordingly, and we can do the rest of the things accordingly. Yes, everybody, all of you. Any questions? We are open for it. I see that some of you are raising your hands, team. Raising hands may not help because I'll not be able to unmute you because most of you are on the web. I don't even have an option to unmute you guys because of the GoToWebinar this one. So what is the difference between a clone and a fork? Okay, great question, Ratan. Clone is something, let's say that from the centralized repository to the local machine, right? That is something called as cloning. Okay, that is something called as cloning. But whereas, let's say that there is a public repository available, let's say that I'm saying that I'm going to a different account right now, which is called as Learn DevOps. Lead DevOps is my account actually. I'm going to do with that. Let's say that there are few projects available here, something called as website. Now this is a public project basically. Try to understand that. If I want to contribute towards this project, because I cannot directly contribute to others their account, what I have to do is like fork this project into my own account, right? You log into your account, there is an option called as fork, right? Let's say simply fork it. Forking means that it is going to make a copy from the others account on the GitHub into your account. That is called as forking, right? So if you like my project, if you are having my project or my logs, if you want to copy it in your thing, you do a fork. Whereas if you want to copy to your local machine, you do a cloning. If you want to copy from account to account on the GitHub itself, then that operation is called as forking. Okay. I hope that is clear. So this is, as you see, that CI pipeline. So what is CD? We're going to cover that, Gautam. Right now we covered only CI because we understood about only few tools such as Jenkins, Maven and everything. In order for you to understand the CD pipeline, which is a continuous delivery or continuous deployment, where we actually deploy the application. Now I'm saying that we generated a WAR file. That application need to be deployed into QA environment or similarly the production environment. So how am I going to deploy this application into various environments using Jenkins itself, right? So when I run the things, it is going to generate the WAR file. It is also going to deploy the application into various environments. That pipeline is called as CD pipeline. But in order to make that happen, you need to understand a few more tools, how to deploy the application, how do I connect to various environments and all those things. That we'll be covering in next 2 days. And in the last day, we're going to show the complete CI/CD pipeline for you. Okay. I hope that makes sense for you now. So I already have JDK in my laptop, so still I have to install in Git. Sarvesh, I think it is, basically, if you are working in your laptop, in the sense, is you working on Windows or is it like an AWS instance? That we need to understand, Sarvesh. Check that. We need to do it accordingly. So because we are working on AWS Ubuntu instance, it is must that you must install on the Ubuntu instance. Whatever is in your local desktop doesn't matter about it. We must install it on the Ubuntu instance account. Okay, what is stash, Pamuleti? Stash is something like saving your workspace into a temporary work area. We call it in Git. So when I say something, what do I say that? Let's say that when I'm working on a project, right? All of a sudden, my manager asked me to do something else, but whatever the project I deleted already, I do not want to delete. Either I want to commit it, right? Because if I commit it, that will be delivered to the end user. I don't want to commit, and at the same time, I don't want to delete the changes. I want to save this, whatever the changes I made it in my Git repository, to a temporary working space where Git see it or Git applies it or saves it safely, so that I can work on the rest of the work and commit them accordingly. That is what is called as stashing in Git. So good. For Java, we have follow the CI pipeline just shown. What if we need to create a Unix scripts where compile is not required? Okay, so see, using Unix, are you developing an application, Nilab Kumar, right? Using shell scripting, you don't develop, right? Shell scripting is for automation, but we are mostly talking about your application development. So whenever you go for application development using a Java or Ruby or Python or whatever it may be, .NET, we always do the compilation. That is what it is. So shell scripting is just a script basically. It is not something to do with it. So shell scripting is different. Application development is something you need to understand. Right, so kindly please share the PPTs for the reference. You will get that link, Gautam, so don't worry. So simply stash means saving your changes for the future work. That's absolutely correct, Pamuleti. That's it. Instead of committing them immediately, I want to commit something else apart from the changes which I made it. So I put a stash basically, so Git saves them in a temporary workspace. And once I did with the changes currently, I can pull them back again. I can do on working again. I can commit them accordingly. So my project is Unix and OC. See, in that case, basically, right, you need to design a flow. What exactly is it really required? A continuous integration is required for your project. In that case, I don't think so. There is a continuous integration is required for you, right? What exactly your job role defines it, you need to do it. But if you are stepping into the DevOps engineer side, where you may have to work on these kind of projects also, right? Then you, if your role is to do this job, you need to do it. Otherwise, you can stick to your area and you can work on your own area accordingly. That's up to you. Where can we see the mock questions regarding the course covered test understanding? I think Gautam, I think Kumar can answer that one. You must log into your portals, maybe the exam portals, which might not be enabled for you so far. I believe so, right? So whenever there is an exam portal enabled for you, your ID is created on the exam portal. So there you will see the sample questions also. That you will get an email once you register for the exam portal accordingly. I think that will be happening on the Friday mostly. So you will get that questions accordingly. Okay. You will be seeing on the exam portal itself. See, that is what is a problem. I'm not seeing the unmute option for me because most of you have joined from the web actually. As an organization, I'm also not seeing it except that one. We can, I mean, that is a problem, right? That is the reason we're asking you to do it. Maybe for the tomorrow, you might get a link where you can join through the applications mostly than the web. I think Kumar, we need to sort out that one for the people who wants to speak. I can unmute a couple of people, those I can see it, right? For those who want to speak, I can speak it maybe. And rest of the people, I don't have an option. Sachin, Arjit, these people can speak. Srikala can speak if you want it. So, Okay, Pamuleti, we'll try to provide as much as we can, and you can post your questions, what is required in the LinkedIn group also. We'll try to help you as much as you can, as much as we can. So please try to post your questions, whatever you have it in the LinkedIn group. If you have already joined it, otherwise please join to the LinkedIn group, community group, and then you can post your questions there. We all will be there to help your all questions. That is what we can do it. Okay, great. Okay, I think that's all for today, team. I think can we cache the artifacts for every single stage in Jenkins? Every stage does not generate an artifact, right? The package is the job where you are generating an artifact. Otherwise, if you're talking about the results generated by everything, if you want to cache them, yes, you can do that also. That we can achieve it. I'm not sure from whose the question is that. From tomorrow, we'll be sending the fresh invite. Okay, great. Okay, I think Priya, we have used the AWS instance itself on top of only we are actually running the Git and Jenkins, right? It is still the AWS instance, right? We connecting it using the Git bash, we connected to this one. Git bash is just a client using which we connected this one. We started doing things, everything on the here itself, right? We are not working on the Git bash, we are working on the AWS instance itself. How does the QA will come to know whether the code is ready for the QA to test or not? See, QA is always involved with the development team, and whenever they start development, basically they always start with the testing also. They will get information from the developer endpoint itself. Once the deployment is over right now with the continuous integration process, if you are working as a QA engineer, we deploy the application into QA environment. Once the deployment is completed, you will get a notification that the deployed application successfully to the QA environment. Then you QA can come into the picture and start testing your application accordingly. Continuous integration is where QA does not do anything. It is just that the developer endpoint or a DevOps engineer or build release engineer will create this pipeline to deliver the application accordingly. That's all you're going to do it. Okay, great. Should we show an example merge conflict? Git bash. Okay, we'll try to do that. From tomorrow. Okay, great. Today we did AWS. Okay, that's fine. We did use Priya, as I just told right now, everything we are doing on AWS instance itself, we created yesterday and we are logging into the same instance, right? So we are logged into this one. This is Ubuntu instance only. Here, everything I installed on the Ubuntu itself, right? Jenkins, Java, everything was installed on the Ubuntu instance itself. And we are still, everything is working on the Ubuntu only. We are just connecting to the Ubuntu using Git bash, that's it. Everything is performing only on the Ubuntu. We are not doing anything on the Git bash. Git versus GitHub difference, please. That's I already told you, Priya. Git is a client that you install on your machine, just like this one. Think that you have creating your files on your machine. That's it. GitHub is like your Google Drive where you want to save it centrally, right? Means if you have something in your local, if your laptop is crashed, something can be getting from the Google Drive again. So GitHub is like your Google Drive where you save the content in online or centralized location. Whenever you want to get the changes back to your machine, you can get them back, or whenever you make some changes in the local again, if you want to update the centralized repository, we can update it. Like your local desktop to the Google Drive. Local desktop is nothing but your Git client, which you install on the local system, and GitHub is like your Google Drive, where you upload the changes and keep it safe there so that multiple people can see the changes, or you can upload or you can download from there again. That is the difference between the Git and GitHub accordingly. Okay, so I see something here. So I need to SSH to the Ubuntu instance again after the Git bash session is inactive for some time. Can I change some settings somewhere to have the session? Okay, Gautam, let me see if I can provide you something. Just give me a second. Just give me a second. If there is something in the AWS, I'm going to show you. Here it is, right? I'm just checking if there is some scripts are available. Okay. Okay, I'm just going to provide a script basically. So just simply use that script to run it on your system. Okay. Here it is, Gautam. Okay. Whatever I'm giving the link right now, just run the script or download the script and run it on your machine. So you'll be able to see that account, whatever you're requesting for it. Git client versus Git SCM. What do you mean by Git SCM here? Git SCM or Git client are one in same, right? Git source code management, we call it. So Git is a client which is managing the source code accordingly, right? There is nothing, Git SCM is nothing but Git client plus Git, the GitHub together, we call it as a Git SCM actually. Git client is something you install on your machine probability. That is what. So whatever we install on our Linux machine, that is called as Git client. Git SCM is nothing but the combination of Git client plus GitHub is called as Git SCM altogether. Git source code management, we call it. Okay, or GitHub can be treated as your Git SCM again accordingly. Okay. So I think that's all for today, I believe. If anything else, let me know, team. Otherwise, we'll wind up here and we'll see you tomorrow. Okay, team.
Thank you,
So
Naresh.
have a yeah.
I
Thank
think
you.
we are good. Thank you so much. Just one update, quick update, guys. We are going to send out a fresh invite, to avoid the technical goof up which we had. We got an update from GoToWebinar, and we are able to rectify the same. So, and second thing, we'll be sending separate email with GitHub Git URL and the recorded sessions to all of you, so that you will keep it handy. So, and also we are will start tomorrow. We'll start this session little early, at least 15 minutes early, at 8:45, so that you'll get sufficient time, and we can avoid these late joinings or initial technical hiccups which you guys were facing, so that we can close our session well on time. So thank you so much, and thanks again for bearing with us. These were technical challenges where we do not had control. So thank you once again.